So once again, let's quickly take a look at how we're going to handle logging in the user. More specifically, how do we actually verify that his credentials are correct? Because it's not going to be exactly the same way that you would think. So the user is going to hit the login endpoint and he's going to provide the email and the password. And I've colored the word password in red because this password is going to represent what the user is trying to log in as. This is his attempted password. That's what we're going to call it. And that's going to be in red. And keep in mind that when he sends this password, it's in plain text, right? It's just the regular password that he typed out. And so when it gets to our API, the first thing that we're going to do is we're going to hit our database to try to find the user based off his email or his username. And the database is going to send back all of the information about that user, which includes the password. However, if you remember how we actually created the password and stored it in the database, we actually stored a hashed version of the password in the database so that if anyone hacks our database, the user's passwords aren't actually in plain text, so no one can really hack their passwords. But this creates a little bit of a problem because we have the attempted password for the login attempt in plain text. However, we've got the password in our database as a hashed password. So how exactly do we check to see that they're equal? Because right now, a hashed password does not equal the same as the regular password. And your first instinct is to, hey, well, let's just convert this back to a plain text password. And we can't exactly do that because remember, a hash is only one way. So if we hash a password, we can't get the original password from the hash. That's what's great about hashing a password. And if you think you can do that, that's actually, well, I guess what we would refer to as encryption, but we're hashing in this case. So what do we do to verify if the passwords are actually equal? It's pretty simple. We take the hashed password and then we take the raw, and once again, this hashed password is the correct password in our database. Then we take the password attempt and we hash it again. So we hash this password. And so then we get a hashed password. And so if we have the correct password, then if we put it through the hashing function, these two should be equal. And so if they're equal, that means the password they provided us is the correct password in the database. If they don't match, that means he gave us the wrong password. And so if they're correct, we'll then go ahead and we'll create a token first, and then we'll send it to the client. So it's as simple as taking the attempted password, hashing it, and then comparing it with the hashed password in the database. Because if the passwords are correct, then the hash should equal the hash in the database. Okay, so we're going to create the login path operation. And what I'm actually going to do is you're probably thinking that we can just store the path operation in the users.py router. However, I think it would make more sense to actually store this in a authentication router. So we're actually going to create a brand new router for this so that we can keep the user routes versus the authentication routes in two different files. However, if you really wanted to, you could store it all in one file. So I'm going to call this auth.py. And the first thing that we have to do is from the Fast API, we're going to import a few things. We're going to import the API router. We're going to need depends, status, HTTP exception, and maybe we need the response. I haven't decided. And then we're going to define our router. So we'll say router equals API router. And we're going to pass in a tag, just for the documentation. So we'll say tags equals authentication. All right. And then we're going to create our login. So we'll call this, first of all, this is going to be a post request because remember the user is going to have to provide his credentials. So generally when you want to send data in one direction, it's going to be a post request. And we'll send it to the login endpoint. You can call this whatever you want. You can call it authenticate. However, I like login. And then we'll define our function, and I'll just call this login as well. And because we're ultimately going to have to fetch the user from the database, we're going to have to import our database session. And so from SQL Alchemy, we'll say .orm import session. And so we'll do the same thing that we did with every other path operation. I'll say db session equals depends. And then we're going to have to actually import our getDB function. So from here, we'll do from, and we have to go up a directory, and I'll say database import session. Sorry, not session. Actually, you know what I'm going to do? I'm just going to say from ... import database. And then I can just reference it as database dot get underscore DB. Right? And since the user is going to be providing the login information, I think it makes sense to set up a schema so that we can ensure that they provide the exact pieces of data that we ultimately want. And what we're going to do is we're just going to create a new class, and I'm going to call this user login. And this will extend the base model as usual. And the two pieces of information that we want are email, which is going to be a string, and then we can do password, which is going to be a string. Actually, I'm gonna use an email string like we did before. And then from our auth.py, I'm also going to import schemas. And here I'm going to store the schema as a user credentials. This is going to be schemas.user login. All right, and so now we can access all the user information or the attempted login information with the user credentials variable. And we're going to make a request to our database, specifically our users table, to retrieve the user based off of his email. So we'll say db.query, and we have to import models now so that we can access it. And we'll say models.user, and then we have to filter based off of the email. We'll say models.user once again, .email equals user underscore credentials .email. And then there's only going to be one user with that specific email, so we'll do first. And we'll store this result in a variable called user. Now, if there's no user with that specific email, then we're going to return a error, or we're going to raise an exception. So we'll say if not user, we're going to raise an HTTP exception. And the status code is going to be status dot, and I'm trying to remember what code will, oh, it's going to be a 404 because that user doesn't exist. And then the detail field, we're just going to say invalid credentials. Because normally with authentication, you don't want to say, hey, this is the wrong email or this is the wrong password, because you don't want to make it a little bit easier for them to kind of guess other people's information. Just say this is invalid credentials, let them figure out whether it's the email or the password. And then after this, once we verify that we did actually get a user object, we have to verify that the passwords are equal. So this would be, performing that logic of hashing the password that they gave us and seeing if that it compares to the password from the database. And so what we're going to do is we're going to create a new function in the utils folder that's going to be responsible for comparing the two hashes. Or actually, it's going to take in the raw password, the password attempt. It's going to hash it for us, and then it's going to compare it to the hash in the database. So we'll create a function, we'll call it verify, and it's going to include the plain password, which is the password the user is trying to attempt, and then the hashed password, which comes from the database. And all we have to do is just return, and then we can reference the PW context, right? So if you want to hash a password, you just call the dot hash method. However, it's also got another method for us, which is verify. So it's going to perform all this logic for us. So we just pass in the plain password, and then we pass in the hashed password, and it's going to figure out the rest. Now you're thinking, well, what is the point of such a tiny function? Why don't we just include it in our auth.py? Well, we 100% could, because it's really 2 lines of code. It doesn't really make sense to store it in another file. However, then we also have to import all of the bcrypt code, and I like to have everything kind of separate. So keeping all of the bcrypt logic in one file just makes things a little bit easier to manage. But in our auth folder, we can import utils now. And we're going to run the utils.verify. And we're going to pass in the plain password, which is going to be stored in user credentials. So we'll say user credentials.password. And then we pass in the hashed password from the database, which is stored under user. So we'll say user.password. All right. And if they are not equal, so if they do not equal each other, which means they provided us the incorrect password, then we're going to raise another HTTP exception. And this is going to be the same thing. We're going to send a status code of 404. And the detail is going to be the same thing. We're not going to tell them that it was the wrong password. We're just going to say invalid credentials so that it's not easy for them to kind of keep guessing passwords or emails. All right. And then at this point, what we would do is we would create a token, which, we haven't really gone over how to do that. And then we would just return token. But once again, we haven't done that. So I'm just going to return, and we'll just say token. And I'm just going to say example token, right? Because we haven't implemented that logic, but I do want to make sure that the rest of the code looks good. So we'll try that out. And I'm going to go in, create a new request. This will be login user. It'll be a post request. I'm going to copy this. Actually, this is just going to be /login. And then in our body, we're going to provide some JSON. And here we're just going to say email is whatever. And password is whatever. And before I actually do anything, I'm going to run a query on my database because if you see, I've got a couple of users that don't have hashed passwords. So I'm actually going to delete everything just so I can clean up some mess. And I'll just say, and what I'm actually going to do is I'm just going to delete everything. I think that's going to just make things simple because I don't even remember these guys' passwords. So it's going to create some issues for us. So we'll just say delete from, and I'll say users, and then I just won't provide any condition. So this should delete everything. We'll run that, and you can see that it looks like it deleted all 12 results, and that's perfectly okay. And I'll add my original query back, select star from users. And what we're going to do is we're going to just register a new user. So I'll do create user, and I'm going to call this Sanjeev@gmail, and then the password is going to be password123. So let's create that user. Let's take a look. All right, we've created that user. And now let's log in this user. So we'll go to login, and I'm going to provide my Sanjeev@gmail. And then we're going to provide a password, which was password123. Let's try this out. And it looks like we ran into an issue. So well, first of all, that's the wrong error message. I'm not sure why it gave me that. It should say invalid credentials. So where is this actually happening? And guys, I made an absolute silly and stupid mistake. I forgot to actually wire up this router in our main.py file. So it doesn't even know about it. So let's import this. We're going to say import auth. And all we have to do is just one skin. I'm just going to copy this. And we'll just say auth.router. All right, let's try this again. All right, and we've got our example token, which means that we verified that the passwords are correct and everything was good to go. We just haven't implemented the logic for the token, but let's just make sure that when we put in the wrong password, it still works, or it shouldn't work. And we get invalid credentials. Let's put the right password back in, and then let's use the wrong email. And we get invalid credentials as well. So so far, we are almost done with the whole login process. The next thing that we got to do is handle creating a token. It's not going to be too difficult, but I do want to save that for the next video. Now, if we head on over to the Fast API documentation under security, there's going to be OAuth with password. And so most of the things I cover are going to be coming from this documentation right here. Now, the first thing that we have to do is we have to install a library that handles signing and verifying JWT tokens. And so we're going to use this Python-Josie library, and then we have to provide a cryptography backend. So we're just going to copy this line right here, and we're going to run this in the command line. And what I'm going to do is when it comes to authentication and anything with JWT tokens, I'm going to create a new file, and I'm going to call this OAuth2.py. All right, and the first thing that we're going to do is we're going to import from Josie. We're going to import JWT error and JWT. Now, there's going to be three pieces of information for our token. Well, actually, there's three pieces of information, but there's three other things about the token that we need to provide. So we're going to say we're going to need the secret key, right? That's that special key that I mentioned that ultimately handles verifying the data integrity of our token, which resides on our server only. So we're going to have to provide that secret key. We're also going to need to provide the algorithm that we want to use. We're going to be using HS256, and then we're going to need to provide one other thing, which is the expiration time of the token. So we haven't really discussed the expiration time. If we just give a plain token without an expiration date, that means that user's logged in forever. And there's no application that just lets a user log in forever, I don't think. So we're going to provide a expiration time so that we can dictate exactly how long a user should be logged in after they actually perform a login operation. And so we need an expiration time. And what I'm going to do is I'm going to just save these as variables. I'm going to say secret key equals, and then this is just going to be some arbitrary long text. I'm just going to paste that in here. And if you're just wondering why, if you just follow the documentation, actually, you'll see that they do the same thing. So we just need to give it some really long text in this case. And it even gives you a command to kind of get a string like that for your password. Because you could theoretically just put, hello or something here, and that's going to work just fine. However, it's not quite as secure, but for learning purposes, it doesn't matter. Just provide some kind of string, right? And then the algorithm is going to look like this, and then the expiration time is going to look like this. So I'm just going to copy this from the documentation. And then we're going to define our function. So this is going to be create access token. And what we're going to do is, remember, the access token is going to have a payload. So whatever data we want to encode into the token, we have to provide that. So I'm going to pass that in as a variable called data. And this is going to be of type dict. And what we're going to do is we're actually going to make a copy of this data because I don't want to actually change it. I want to make a copy of it because we're going to manipulate a few things, and I don't want to accidentally change the original data. So we're going to say data dot copy. So this is going to make a copy, and I'm going to store it in a new variable. And it's going to be 2_code. So this is all the data that we're going to encode into our JWT token. And then now we're going to create the expiration field. So to actually do that, there's a couple of things. First of all, right now we have it set to 30 minutes. And so what we need to do is to provide the time of 30 minutes from now, right? So we have to provide the time that it's going to expire in. So we have to grab the current time and then add 30 minutes. And so anytime you're working with dates and times, we have to import the date time library. We'll say date time, import date time, and time delta. And I'm going to say expire equals date time dot now. So this is going to grab the current time. And I'm going to pass in time delta of, and then since this is in minutes, I would say minutes equals access token expire minutes. And then what we want to do is we want to grab the to_encode, which is a copy of a dictionary. So this is also a dictionary. And I want to update it. And here we're going to pass in expiration, and then we're going to provide the expire time. So we're just adding that extra property into the into all of that data that we want to encode into our JWT. And so now our JWT will tell us when it's going to expire. And what we're going to do is we're going to call JWT, coming from the, is it Jose? I guess it's the Jose library. So JWT.encode, so this method is actually going to create the JWT token. And we'll say the first property is everything that we want to put into the payload. The second one is going to be the secret key with the signature. And then we have to specify the algorithm. So the algorithm equals algorithm right there. And then at this point, we're just going to return, oh, we have to save this in a variable. And here we just do encoded JWT. And then now we can go back to our specific path operation. And since we're already importing, actually we have to also import OAuth 2. And then here we're going to create an access token. And we're going to call the, sorry, not utils, OAuth 2 dot create access token. And we're going to say the data equals, and then we're going to pass in a dictionary. So here, the user ID field. Remember, this is the data that we want to put in the payload. So I have decided that I'm going to put in the user ID and pretty much nothing else. I don't really care about anything else. We could give it a role, we could give something else, but for me, I just want to encode the user ID. So that's what I'm passing in here. However, if you wanted to provide some extra information about the user, if you wanted to provide their scope of different endpoints they can access, you can put all of that information in here. And so I'm going to say the user ID is going to be set to user.id. And so now what we can do is we're going to return a few things. I'm going to say we're going to return the access token, which equals access token. And then we're going to tell the user what kind of token this is. So this is token underscore type. And this is what's referred to as a bearer token. And I'll explain how to actually configure that on the front end. But literally in the authorization header, we just write the word bearer and then we provide the token. So nothing special there. All right, let's try that out. And it looks like I got an error. And I don't know why I put an equal sign there. And let's try this out. So we've got the login endpoint. Let's put in the correct email this time. And let's see what happens. Look at that. We got an access token. And this kind of looks like a JWT token, right? It just looks like a bunch of random text. And then it tells us it's a bearer token. So let's actually copy this. And what I want you guys to do is go to your web browser, and I want you to search for JWT. And then go to go to jwt.io. And then here, what we can do is we can paste in our JWT token. And what's really cool is it's going to decode the token for us. And so you can see this is the algorithm we used. It is a JWT token. But take a look at the user ID. Right? This is the actual user ID that we passed into the token. So all of the data that we encrypted into the token are all sitting right here. So we also got the expiration time and then the signature somewhere in here as well. But isn't that pretty cool, right? It was able to decode that. And it's important to understand that, none of this is encrypted. Anybody can see this information, but by being able to sign it, we know that no one can kind of mess with it. And we can also specify an expiration time. So we know that how long this token is valid. So when our API gets it, it's going to just verify that nobody touched the token. It's going to verify that, hey, the expiration time, isn't before the current time, which would mean that it's already expired. And at that point, it already knows the token's valid. And then we can assume that everything is good to go. We're going to make one small change when it comes to retrieving the user's credentials in our login route. Instead of passing it in the body, we're going to use a built-in utility in the FastAPI library. So if we do from fastapi.security.oauth2, we're going to import something called OAuth2 password request form. And so what we can actually do is instead of just doing the usual here with the user credentials, we're actually going to delete that. And I'm going to provide a dependency. Well, actually, I need the user's credentials because we have to store it someplace. But here we say this equals OAuth2 password request form equals depend. So we're setting up a dependency kind of like we do with the database. And so this is going to require us to retrieve the credentials, and then FastAPI is automatically going to store it inside this variable called user credentials. However, we have to make one small change. So the username when you retrieve the user's attempted credentials from here, what it's going to do is it's going to store it in a field not called email, but it's going to store it in a field called username. So when we compare the models.user.email when we're querying the database, we can't compare it to user_credentials.email because there's no field called .email, right? It's going to only return two things. It's going to return, it's going to return something. It's going to return our username, which equals whatever, and then it's going to return our password, which equals whatever. And so we don't have access to email. We have to use user_credentials.username because, this is actually a bad example because you have to think of it as like a dictionary, right? It's coming in like this, and then there's going to be a user field. You're going to have username. Oh, why is that capitalized? Username, which equals blah. you're going to have username, which equals, blah. And then you're going to have password, which equals blah, right? And so we'll just tag user credentials dot, and then we'll grab the username, which in our case will happen to be the email. The OAuth 2 password request form doesn't really care what the username is. It could be a username, it can be a email, it can be an ID. It doesn't really matter. It doesn't really care. It's just whatever the user actually sends. It's just going to store it in a field called username. So those are all of the changes that we have to make from our backend side. Now, when it comes to testing things, we no longer send the credentials in the body like we normally do. Like if I try to send this now, we're going to get an error, right? Because it says username is field required value error missing. So and the password is also missing. So what it's doing is it no longer expects it here. Instead, it expects it inside form data. So here I'm going to say username, and this is going to be my email in this case. And then my password here. And so let's try this now. And now it successfully works. So those were the couple of changes that we have to make. But you'll see that it makes life a little bit easier by setting up that dependency and using the built-in functionality of Fast API. In the last lesson, we learned how to log in a user by sending a request to the login endpoint and providing the username and password. And our API will then return an access token, which the user can then use to retrieve data from our API. So anytime he needs to access a endpoint or path operation that requires a user to be logged in, he'll just send this JWT token in the payload, and then our API has to actually validate the token. So in this video, we're going to handle the logic for verifying that the token is still valid, then that they didn't tamper with it, as well as verifying that the token hasn't expired. Now, before we do anything, what we're actually going to do is we're going to define a schema for the token. Because we know that the user has to provide the access token. So just like any other piece of data, if we expect them to send something, it's best to set up a schema. So we're just going to set up a schema for access token and token type and just make sure that they match accordingly. And so here we're going to do class token. And we'll say the access token is going to be of type string. And the token underscore type is going to be of type string as well. And then we can also set up a schema for the token data. So the data that we embedded into our access token. So we can say token data base model. And then here we did embed the ID. But I'm going to say this is optional for now. And it's going to be a type of string if it is set. So it can be optional, and we got to import optional as well. And so that's going to come from the typing library. And then in our OAuth 2 file, we created an access token function, and then we have to create a function to verify the access token. So let's create that function, and it's going to just be called verify access token. And what we're going to do is we're going to pass in a token, which is going to be a string. And we're also going to pass in the specific credential exception. So we're going to pass in what our exception should be if the credentials don't match or if there's some issue with the token. So we'll just store this in a variable called credentials underscore exception. And I'll explain this a little bit later. And so here I'm going to say JWT, right? So we're going to access the JWT library. I'm going to say JWT dot, and then it's going to have a function. And if you take a look at our options, I'm sure you have an idea because creating a token, we did encode. I'm guessing you can figure out what is the specific method for decoding. It's going to be decode, obviously. And here we're going to pass in a couple of things. First of all, the token. Then we have to pass in the secret key so that we can decode it. And then we have to pass in the algorithm that's used. So we can just pass in algorithm. Once again, both of these are coming from these variables right here. It's obviously not a good idea to store the secret key within your actual code. But like I said, we're going to have a later section where we'll turn these into environment variables so that it's not hard-coded into our code. And we're going to store this in payload in a variable called payload. All right, and so this will just store all of our payload data. And to extract the data, what we can do is we can say payload.get, and then we have to get the specific field that we put in. So if I go back to my auth.py file in my routers, and you take a look at my data, you can see that we have a field called user_ID, and that's going to get the ID of the user. So here we just say get, and then we just pass in that same exact name, users_ID. And we'll say that this is going to be stored in a variable called ID, and this should be of type string. And if there's no ID, then we're going to raise a credentials exception, right? So whatever exception we provided into this function, it's going to raise that. And then we're going to say token_data equals schemas dot token data with the ID equals the ID that we extracted out of here. And I see that we didn't import schemas, so I'll import that real quick. So we'll say from dot import schemas. And so all this is going to do is just going to validate, that it matches our specific token schema. Now, if you look at our schema, right, it's literally one thing. So it's not super exciting, and I made it optional. So we shouldn't actually make it optional, but we'll come back to fixing this in a bit. But this is just going to ensure that all the data we pass in the token is actually there. And so that's why I'm using a schema for that. However, for one actual variable, you don't actually need to do that, especially since we're checking to see if it exists right here. But it's good to always make sure so that in the future, if we do add extra fields, we can also validate the schema here. Now, we're almost done with this function. However, there's one little issue because we can run into an error in any one of these lines. And so anytime you're working with code that can error out, you want to do a try except block. So we'll do try. And then I'm going to indent these. And then here we'll say except. And then we're going to pass JWT error. And this should not be capitalized. And remember, this is coming from the Jose library. And once again, we're just going to raise a credentials exception if there's any kind of error that we didn't account for. All right, and the next thing that we have to do is define one last function. And this is going to be called get current user. So what this is going to do is, what this is ultimately going to do is that we can pass this as a dependency into any one of our path operations. And when we do that, what it's going to do is it's going to take the token from the request automatically, extract the ID for us. It's going to verify that the token is correct by calling the verify access token. And then it's going to extract the ID. And then if we want to, we can have it automatically fetch the user from the database and then add it add it as a parameter into our path operation function. So here, all we're going to do is we're going to pass the token. And so this is going to be a type string. And then here we just say depends, which has to be imported from the Fast API library. So we'll say from Fast API import. We're going to import depends, status, and HTTP exception. So here we'll say depends, and then we'll pass in a OAuth2 schema or OAuth2 scheme. So what we have to do here is, it's going to be a little bit confusing. We'll say OAuth2 scheme. And this is going to be equal to, and we have to import one more thing. So we'll say from fastapi.security import OAuth2 password bearer. And then here we just reference OAuth2 password bearer. And what we have to do is we have to provide one field called token URL. And so this is going to be the endpoint of basically our login endpoint. And so if you go to your auth.py, you just grab whatever name this is. Keep in mind, you don't have to name it login, but you just have to pass this into here. Actually, sorry, you remove the slash. So it's just login. And then we're going to grab this variable and I'm just going to pass it into here. And this is kind of just tying everything together. And then we have to define our credentials exception that we're going to pass into the verify access token function. So when the credential is wrong or there's some kind of issue with the JWT token, what exception should we raise? So here I'm just going to say HTTP exception, and we'll set the status code to be a 401. So unauthorized. Detail, here I'm going to pass a string. Once again, could not validate credentials. And then we have to set some headers as well. And so just go ahead and just copy this in. And then finally, we're going to return a call to our verify access token function. And since we have the token passed into the get current user, we can pass it into our verify access token. And then we also can provide the credentials. All right, so just to quickly recap, because I know we did a lot and I think some of it may be confusing. But what's going to happen is anytime we have a specific endpoint that should be protected, and what that means is that the user needs to be logged in to use it, what we're going to do is I'm going to, well, as an example, let's say that users who want to be able to create a post, they need to be logged in. What we can do is we can just add in an extra dependency into the path operation function. So I can say here, I would just say get current underscore user, which would return an int. And then we'll say this equals, and then we pass in a dependency. So we'll say depends on OAuth2.get underscore current user. So this is going to add a dependency, which is going to be that function that we created called get current user. So anytime anyone wants to access a resource that requires them to be logged in, we're going to expect that they provide an access token. And then we provide this dependency, which is going to call this function get current, get current user. And then we pass in the token that comes from the request. We're going to then run this verify access token in this case. And then it's going to provide all of the logic for verifying that the token is okay and that there's no errors. And if there's no errors, then we go ahead and return nothing essentially. And that means that they were successfully able to be authenticated. If we do return some kind of error with the credentials exception, then they're going to get that appropriate 401 response back. So that's how our login works. It's nothing special, but there are a couple of different components that are involved. And in the next lecture, we'll start to take a look at starting to protect our specific endpoint so that it forces users to be logged in to actually perform that operation. All right, guys, I made one little mistake. In the verify access token function, I forgot to return something. And so if you ran into any issues, it's because of this. So what we're going to do is here, we're just going to do return token underscore data. And so what's really happening here is, once again, we're going to decode the JWT. We're going to extract the ID. If there's no ID, then we're going to throw an error. And then we're going to validate with a schema the actual token data, which in this case is just an ID. So that's the only field. But if you had extra properties or extra information, you can pass that in. And then we want to make sure we return the token data so that we can actually make use of that data. And keep in mind, remember, the get current user is what actually calls the verify access token. So when it calls verify access token, it expects us to return the token data. And then when we get the token data, we return it to whoever calls this function. Okay, guys, so I found a few extra bugs that we need to fix. Now, the first thing that I messed up was when we actually set the expiration time under the create access token function, instead of datetime.now, it should be datetime.utc now. This is important because as I was testing it, I kept getting an expiration error, and that's because this should be a UTC now. And the second thing is we want to put this in brackets because I guess it expects a list of algorithms maybe. We'll put that in there. And then finally, this is also a bug right here because if you take a look at the payload, when we create the token, which I believe should be in the auth.py, when we log in, we pass in the data as user underscore ID and not users underscore ID like we did here. So remove that. And this should prevent us from running into any other potential issues in the upcoming lectures. Sorry about that. I know we ran into a couple of bugs, but that's what happens when you try and copy and paste really quickly. Before we wrap things up, there's one last change that I want to make. Inside the login route in the auth.py router file, I noticed that for the response or the exception that we raise if either the user's email is wrong or if their password is incorrect, I used the wrong HTTP status code for the exception. And I can't remember what I actually had it before because I went ahead and fixed it. But I want you guys to go ahead and change the two exceptions here in both of those cases to a 403. I think that's a better representation of what we should be sending when the user doesn't provide proper credentials. So just update it here and then update it here as well, and then you guys should be good to go. Okay, guys, we're pretty much done with all of the authentication side of things. The only thing that we have to do is require the user to authenticate, because right now, if we perform any operation like creating a post, you can see that I could just create a post and that's it. I don't have to log in first. I don't have to do anything. So anyone can create posts, anyone can delete posts, anyone can do anything they want. Obviously, that's not how your API is going to work. You're going to want to ensure that users are logged in to perform certain operations. And there may be certain operations where they don't necessarily need to be logged in depending on how you want to structure your application, right? Because, if it's like a Twitter-like application, right? Anyone can see anyone's tweets. I just can't delete anyone else's tweets, right? And to create a tweet, I have to be logged in. And so it depends on what you want to do for your application. But what we're going to do is we're going to start off by forcing the user to be logged in before they can create a post. And doing this is actually really simple. So let's go to our post.py and let's find our create posts. Now, the first thing I want to do is I'm going to import OAuth 2, which is coming from this OAuth 2 py file. And then in our create posts path operation function, we're going to add an extra dependency. And this dependency is going to be the get current user function that we defined in our OAuth 2 file. So we'll say is depends, and then we'll say OAuth 2.get underscore current user. And then we're going to store this in a variable called, let's say user underscore ID. And this is going to be a integer. Okay, and so all this is saying is that this function is now going to be a dependency. So this is what forces the users to have to be logged in before they can actually create a post. And so when this function is called, whenever they hit this endpoint, the first thing that we're going to do is we're going to call this function. And this function, all this function does is really just call the verify access token and passing in the token which comes from the user. And so it takes the token. We first decode the token. We extract the ID from the payload. And if there's no ID, we throw an error, and then you can see we validate the schema. And then this is something I actually added in off camera, so we can just delete that and then go back to what you guys have. But we ultimately return the token data, which is nothing more than the ID, right? So we could rename this as ID for now, but like I said, in the future, you may want to add extra fields into the payload, and then it's no longer just the ID, it's going to include extra information. So we're going to return the ID, which then gets returned by the get current user function. And then in our post.py, in our function, we're going to return the ID and store it in a variable called user ID. And so then we can ultimately access the user ID by just calling user underscore ID. That's it. And we can do whatever we want with this user ID, and you'll see we'll eventually add some more logic. But for now, I'm just going to print it out just to see what we see. And let's go ahead and try this. So first of all, I'm going to create post, and then we're going to see what happens now when I try to create a post. Look at that, not authenticated. So by putting in that extra dependency, we have ensured that the user has to be authenticated before they can use this post. Now, how do we actually provide the token so that we can actually use the create post? Well, first of all, let's get a token. So we're going to go to the login user. I'm going to hit send. I'm going to get a brand new token. And then what we want to do is we want to go to create post. And then we want to go to headers. And then we want to create a header. And you can see I created one already, but I'm going to type this out for you from scratch in the line below it. So we say authorization is going to be the key. And then the column is going to be, and you type the word in bearer because it's a bearer type token. So you do bearer with a capital B, space, don't forget the space, and then paste it in. Okay. And so now this is included in our header. And so we should be able to send a request. And so now look at this. We were now successfully able to send our token. The API was able to validate. It was a valid token. And it was able to then allow us to create a post. And just another little Postman tip. You can uncheck this for now so that it's not authorized for you. If I try to do it now, you see I get an error. You can go into authorization and then just type in, go to bearer token and then paste it into here. Does the same exact thing. It's just you don't have to type in the word bearer for yourself and then have to do all of that. You could just hit send now, and it does the same exact thing, whichever method you prefer more. Now that we've protected our create posts route, let's go ahead and do this with some of our other routes. So it's just a matter of just copying the dependency for get current user, and then for retrieving a post. Well, remember, this part is up to you. You decide ultimately what routes you want a user to be logged in to actually perform an operation. But for delete posts, I'm definitely going to force a user to be logged in. And for update post, I'm going to do the same thing. And then finally, like I said, for getting posts, it's really up to you. We'll say that you have to be logged in to do anything. So for get posts or getting all posts, we want to make sure that they're logged in. And then for getting an individual post, we want to make sure that they're logged in. And then finally, the last thing that well, it's not the last thing, but one of the things I forgot to do is under auth.py, when we send our access token after they log in, if you remember under schemas, we actually created a token model, token schema. We never actually used it. So let's actually use that by setting the response model here. And this is going to be schema.token. Schemas.token. So let's save this. And this should be capitalized. Sorry about that. And so now if we log in a user, we should still get no errors. So perfect. Okay. So just in case in the future we accidentally change something, we're still going to perform that validation to ensure that the token, we only send those two fields when we return a token. Now let's quickly just test all the other routes. So if I do get posts and I hit send, you can see, well, let me save everything. Sorry about that once again. Now if I hit send, you can see I'm not authenticated. So I have to do the same thing. So once again, you can do authorization bearer, or you can go to authorization and then just select bearer token and then paste in the token. And now if I hit send, oh, sorry. I got to recopy the token again. Now if we send, it works now. Get one post. Let's try this. Not authenticated. We'll go into authorization, bearer token, send. That works. Deleting posts. Go to once again to authorization. There's no post with an ID of 3, about 4. All right, that worked. And then finally, update post. We're going to do the last thing, and bearer token. All right, and that works. And then let's just double check to make sure that if there's no token, what happens? Error. Perfect. Okay, guys, so I think that's going to wrap up this video for now. We've pretty much done all the authentication that we need to do up to this point. There's one last thing that I want to test to verify that everything works the way it should. And we probably should have tested this in one of the previous videos, but I forgot to do it. And I want to make sure that we test the expiration process, because a JWT has an expiration time that we set ourselves. And this just ensures that a user is logged in only for a certain amount of time. Now, we set the access token expiration time to be 30 minutes. And so that means that if a user logs in and he keeps his token for more than 30 minutes, after that 30-minute mark, if he tries to use that token to access any of our endpoints, it should throw an error because it's already expired. So let's test this out. And the easiest way to test this is, first of all, we're not going to wait 30 minutes. That's ridiculous. So what we're going to do is we're going to set this to 1 minute. And we're just going to test this real quick. And so I'm going to log in this user. So this token is valid for exactly 1 minute. And so we'll go to create post. Actually, we'll just do get post. It doesn't really matter. And I'll paste this in here. And you'll see this works. And we're going to just wait for 1 full minute. And after 1 minute, let's just verify that we get a unauthorized error because the token has expired. Okay, so it should be about 1 minute now. And so if we test this, we should now get an error. So after 1 minute, it says it could not validate credentials. Now we could set up a log message to say that, hey, this token is expired, but we don't need to worry too much about that. As long as it throws an error and it gives them a 401, I think that's good enough for now. And so this confirms that our expiration functionality works. And the last thing to do is, well, let's make sure we change this back. So once again, it doesn't matter what time you choose. It's up to you. I'm just going to do 30 minutes. Actually, I'm going to do 60 minutes just for testing purposes. Moving forward, I don't want to have to continually get a new token after every 30 minutes. So 60 minutes is a good number. Now, you might be wondering, why exactly do we have this get current user function when all it really does is just call verify access token? We could completely just remove this and just call this directly whenever we want to authenticate a user. And you absolutely could with the current implementation. But the idea behind the get current user function is that once the verify access token returns the token data, which is the ID, the get current user function should actually fetch the user from the database. And so that way we can attach the user to any path operation and then we can perform any necessary logic. Now, you don't actually have to fetch the user here. It's up to you how you want to implement this. If you want each of your path operations to fetch the user themselves, they have the ID, so they can do it themselves. However, if you wanted to automatically do it here, you 100% can do that. And so I'm going to show you guys how you can do that in this lesson. And so keep in mind, we get the token data back, which is going to be nothing more than an ID. And what we're going to do is, first of all, we need access to our database so that we can fetch the users. So from here, I'm going to import database. And within this function, we can pass in the dependency so that we can actually get access to the DB object. So I'll say depends, and then we're going to access database dot, and I already forgot the name of the function. What is it? Get underscore DB. So get underscore DB, and we'll say DB session equals. And then we have to import session from SQL Alchemy. And so now we can make requests to a database. And what we're going to do here is, first of all, I'm no longer going to return that directly. And I'm going to say token equals, and then we're going to call this function right here, verify access token. All right, and since we have access to the token, what we can do now is we can say db.query, and then we have to import models. And I'm not sure if we've done that already. We haven't, so I'll import models. I'll say models.user.filter, and then we want to filter based off of the ID, so I'll say models.user.id equals token, and then we just grab the ID field. And then we're going to grab the first one, and then we can return the user, which I forgot to save it. So user is going to be equal to the result of that. And if you want to, you can print user here, but I already know this is going to work. So we can just go and save this. And then in our post.py, right, when we call this dependency right here, it's no longer returning the user ID. So I don't think it's a good practice to call this user ID anymore because it represents a user. So I'm going to say, I'm going to call this current underscore user, and we're going to rename this everywhere. All right. And then here within the function, I'm going to print out current underscore user. And so if I try to create a post now, and then open up my console, you can see that it printed out the user object, which not very helpful, but what we can do real quick is I'll just say current.user.email. So we can see the email of that user just to verify that we are actually getting the user. And we can see that it does print out the email. So that's ultimately why this function exists, because normally here, this is where you query your database to grab the user and then you return the user. And then whatever you return here is ultimately what allows any of your other routes to get whatever you're returning. So since we're returning a user, we're going to store it as a variable called current user. In this video, we're going to take a look at some of the more advanced features of Postman. And we're going to start off by taking a look at environments. So select the environments tab and you'll see that Postman just gives you a quick description of what an environment is. It says an environment is a set of variables that allow you to switch the context of your request. So we can set up some variables that change depending on what environment we work in. And you're probably thinking, well, what exactly is the point of that? And let me give you a great example. If you take a look at all of our requests, you can see that we hard-coded them to be 127.0.0.1, port 8000. And this is our development environment. Now, when we ultimately go to deploy our app, it's not going to be deployed on 127.0.0.1. It's going to be deployed on some server. It's going to have a public IP somewhere on the internet. And so when we want to test out our production server or make some changes to our production server, make some test requests to it, we would have to change the IP address, the port number, as well as we probably are going to be running HTTPS instead of HTTP. So all of our requests, we'd have to change all of them and then continuously flip back and forth every time we move from dev to prod and then from prod back to dev. And so instead of having to hard code these values and then change it constantly, we can actually create a variable that changes depending on what environment we use within Postman. So let's go to environment and let's create an environment. And I'm going to call this environment, we'll say this is dev, and then our project name, which is Fast API. So this is our environment. And what we can do is we can define a variable. And I'm going to call this one URL. And then here, I'm going to actually just copy this URL. And then go to our environment again. And then I'm going to give it an initial value. All right. And then our current value should update. And then we can just hit save. Okay. And so we've set this variable to be this specific IP in our dev environment. And so if we go back to collections and then go to our Git posts, first of all, now moving forward, you want to make sure that you're working in some kind of environment. So we'll select the environment we just created. And then instead of hard coding this value here, I'm going to change this. And I'm going to just say, to actually use a variable, you do curly brace, the name of the variable, and then curly brace, curly brace. Okay, and it should be orange instead of red. If you get a red, it's going to mean that it wasn't able to resolve something and there's some issue. So just double check what you did. Orange is good. And then if you see this result when you hover over it, that means that everything's working. And so just to quickly test this, you can see that it says could not validate credentials. That's perfectly fine. I didn't set up the access token or anything, but this does confirm that we're able to resolve that variable. And so that way, you know, if I go and then create a new environment, and I'll just add here, and then we'll say this is prod Fast API. We can then give a different URL for the production environment. So this could be like, you know, https:// I don't know, you know, some domain name that you buy. I'll call this sanjeev.xyz/. And then I can save this. And so that way, if you ever are testing your development environment, you just go to dev. And then when you want to quickly switch to your production, you just change to that. And then the URL will automatically update so you don't have to change anything yourself. And it's super handy to set this up. And we're just going to do this for all of our requests moving forward. So I'm just going to copy this. And we're going to do this for all of them. Okay, and if you go ahead and test this yourself, you should ultimately not run into any issues. I'm not going to bore you through, you know, individually testing these. You can do this yourself. And if you run into errors, it's just you probably pasted in something wrong. Now that we've set up authentication on our API, testing our API has gotten a little bit more challenging. And that's because I can no longer just go to create posts and then just hit send. Because I have to be authenticated first to be able to actually create a post. And so what I have to do in Postman is I have to hit send. I have to log in and then get the access token. I have to copy the access token and then go to the specific endpoint I want to test. And then I want to paste that in there and then hit send. And then I can finally create post. And this is a little cumbersome and tiring. And it gets really hard if you have a short expiration time on your token. Imagine if you had an expiration time of 5 minutes. Then every 5 minutes, you'd have to repeat this process. But luckily, Postman has a way to actually do this through an automated fashion. Right? We're all developers. We all want to do things automated. So let's take a look at how we can do this. And I had to make sure that you guys understood environments and variables beforehand because the method that we use actually makes use of environment variables. So let's go to the login user endpoint, and we're going to hit send and get a new access token. And so we've got this access token. And what I want to do is through code, I want Postman to automatically set an environment variable. So how do we do that? Well, let's go to tests. And here we can put in whatever code we want. And so we can read the documentation on how to do this, but the ultimate goal is to set an environment variable through code. So how do we do that? Well, there's a little snippet here that kind of gives you examples. And what we want to do is we want to set an environment variable. And so to set an environment variable, you just do environment.set, provide the key, and then the variable name. And so just like we did with environments, right? If you go into your environment, you've got the URL, which is the key, and then the value. And so we're just going to do the same thing, but just through code. So here I'm going to set the key to be JWT. And I'm going to set the value to be this access token. So how do we actually retrieve the access token from the response of the request? Well, we can do pm.response. That grabs the response object. Then we'll convert it to JSON, and then we need to get the token. And the token sits on a property called access_token. So whatever this field is called, this is what you're going to pass in. We'll say dot access_token. All right. And so now if I send this again, we'll get the token. The code should have run, and it should have set a variable called access token. And so now under create post, instead of hard coding this, what I can do is I can actually just reference the JWT variable. And so I set minus capitals. There looks like there's one from a previous project maybe, but we want this one right here. And if you want to just double check, you could see that this ends in WYD30. And if you want to go back into a login user, you can see that this ends in WYD30. So it looks like it did set that and update it accordingly. So we'll set that in there. And so now if we send, you can see that we can now create posts. And so anytime you log in a user, it's going to update that token. And we can verify this. If you take the last 3 letters, Q0A is the new token. And then I'm going to just remove that so we can see the value. And we can see that Q0A is the last 3 letters as well. So this updates it dynamically so that all you have to do is now just hit login user, and then you can start testing all of your other endpoints. And we're going to update all of the other endpoints as well. So for get posts, I'm going to put that in there as well. And then for getting an individual post, deleting a post, updating a post. We don't need it for create user. We might want to do it for get user if we set up authentication for get user, but we haven't done that yet. So we'll hold off on doing that for now. Now, currently, our application doesn't work like a traditional application would. And the reason I say that is, if you take a look at how everything's been set up, not just in our API, but in our database, we've got 2 tables, a user table and a post table. So we can create, modify, delete users however we want. We can log in. And then we can create, modify, and delete as many posts as we want, right? And you're probably thinking, well, that sounds perfectly fine. Yes, however, think about any other application. Think about any social media type application. When someone creates a post and you see that post on your feed, what are you going to see next to the post? You're going to see the user that created it, right? So every post is ultimately associated with the user account that created that post. But we have no way to actually do that in our application at the moment because there's nothing that ties a post to the user that created it. Right? Take a look at all of the columns in our database. We've got an ID, a title, content, published. Technically, there's a created at column that I didn't draw in this diagram, but that's okay. So how do we know what post was created by what user? And this is where relational databases really start to shine because the main idea behind a relational database is that you set up these relationships between tables. So we need to set up some kind of special relationship between the users table and the post table that will allow us to associate a post with a specific user that created that post. So let's take a look at how we can do that within Postgres or any SQL-based database. And the way we do that is we actually create an extra column in our post table. So we've got a column, you can call it whatever you want, but I'm going to call it user ID and I'll explain why. And what we're going to do is we're going to set up a special foreign key. And a foreign key is how we tell SQL that this column here is connected to another table. And what we do is we specify two things. We specify the table that it should be connected to. So here I'm saying, hey, this should connect to the users table. And then we specify what specific column it should use from that table. And here we're saying the ID column because this connection is connected to the ID column of the users table. And so that's what we set the foreign key on. And all this does is this is really such a simple concept. Whatever user creates this post, we just embed the ID of that specific user. So for the post with the ID of 621, the user that created this has an ID of 212. So if we take a look at what user has an ID of 212, we go here and we can see that clay@gmail.com created this post. And so that's all we have to do to set up a relationship between these two tables. And so now moving forward, any post we create, we'll easily be able to tell what user created it because we're going to embed the ID of that user into this column called user_ID. And if you take a look at the second one as an example, we can see that this was created by a user with an ID of 378. So we go into the user table and we can see that this user is mike@gmail.com. And it really is as simple as that. And this is what's referred to as a one-to-many relationship within SQL or any relational database. And the reason why they call it that is because one user can create as many posts as they want. However, a post can only be associated with one user. Two users can't create a post. And so that's why this is referred to as a one-to-many relationship. One user can create many posts. And that's all we have to do. It is actually that simple. We just create another column, and then we have to specify this special foreign key constraint where we just tell SQL, hey, what table do we look for and what column? And keep in mind, in this case, I'm using the ID of the users table. But when you get a little bit more advanced with SQL and setting up relational databases, you'll find that sometimes you don't have to always point to the ID of another table. There's going to be a lot of instances where you set up foreign keys to other columns that aren't necessarily the ID column, depending on how your relationships are set up and how your application should work. That is a perfectly acceptable thing. There's no specific restriction saying that it has to point to the ID column of another table. And so I think that's enough theory behind foreign keys and relationships. So we're going to connect to our Postgres database in the next section, and we'll start creating that extra column, adding the foreign keys, and then we'll start learning about how to actually work with these relationships. All right, guys, go ahead and open up pgadmin. And before we get started, I'm going to do something a little unusual. I'm going to delete everything from our post table. Now, when it comes to creating an extra column and creating a foreign key, that's not a requirement. You don't need to do that in a production database. I'm just going to delete everything just to make things a little bit more simple moving forward. Because if we don't delete anything, when you start to add columns that especially have a not null constraint, we have to do a little magic to kind of get that to work. And I want to keep things as simple as possible. So what we're going to do is we're just going to delete everything from the post table just to make things as simple as possible. So we could just say delete from posts, and that should delete everything, and everything's gone. And we should be pretty much good to go to actually start setting up our foreign key. So right click on your post table and then click on properties. And the great part about these foreign keys is that, we just have to do this on the post table because it's a one-to-many relationship. There is nothing in the users table that we have to do. So what we're going to do is we're going to go to column, and then we're going to add a new column. And I'm going to call this user_ID. And you can once again name this anything you want. The actual name doesn't have to make sense. But I think naming it user_ID makes sense because this is a column that's going to represent the ID of the user that created our post. The data type, now this is important because the data type of this column needs to match whatever the data type is of the ID column from the users table. So we always set the ID up to be integer, so you want to match this. However, keep in mind that sometimes when you're working with databases, it might be some other data type. Right? If you use big int, you definitely want to make sure that this is also a big int. If you use a small int, make sure this is a small int. If you use UUIDs, make sure that this is a UUID as well. You just want to match up with whatever that column is in that respective table. Now,
we have the options to set this as not null. So right now, we can create a post with a null user, which means there's no user that created this post. And to figure out if you should set this to be not null, it just depends on how you want to set up your application. Should the database allow you to have a post without a user? It's up to you to decide. I'm going to say no for now. I'm going to say not null because I don't want to be able to create a post without a user. It doesn't make sense. All right. And then after that, what we can do is we have to set up our foreign key constraint. So let's go to constraints. And then we want to go under foreign key. So this is where we set up that magical connection between the two tables. Hit the plus sign and then give this foreign key a name. The name of the foreign key doesn't matter, right? It doesn't impact the functionality of anything. This is more just for you as a user to be able to read it a little bit more clearly when you see it on the CLI. But there's a standard convention that we like to use when it comes to naming our foreign keys. What we like to do is we like to take the table that we're working on, so it's going to be posts, and then we do underscore, then the table that we want to set a foreign key to, so it's going to be users, and then we just do underscore F key. Once again, this is just nothing more than a name to describe the foreign key. It's not actually doing anything at the moment. To actually set up the logic of the foreign key, we have to open this up and we have to go under columns. And so this is how we actually set up the relationship. So here we're saying, what is the name of the local column? The column in our posts table. Well, we created our brand new user underscore ID. Then it's going to reference what table? Well, we know it's going to reference the users table. So we select the users table. And then what column from the users table is it going to reference? Well, it's going to reference the ID column of the user table. And then at that point, you just hit plus. It gets added up here. And before we move on, there's one last thing I want to cover because we're almost done. We have to go under actions. And because we're setting this relationship up between two different tables, we have to figure out, what happens when a user gets deleted, right? Because right now, a post is going to have the ID of the user that created it. What if we delete that user? What do we do? So if you go to the on delete section, we have a couple of different options. One of the more common ones is Cascade. And so what Cascade does is, let's say if I have a couple posts that were created by a user with an ID of 7, if I delete that user, then Postgres will automatically go into my post table and delete any posts that were created by that user. And so that's one option. That's what I'm going to use. However, we have other options as well. We can set it to the default value of a column. So if we give the column a default value, maybe we create like a random ID of 0 or something, then it's going to assign all of those posts that were created by the deleted user to 0. We can set it to null. So if we did set null, then it's just going to set the user ID column to null if that user gets deleted. Keep in mind, if you want to be able to use set null, then you have to go back to columns to make sure this is not set to allow you to set it to null. So we'd have to set it to no, or then it would throw an error when you try to delete someone. And then there's a few other options, but we're going to stick to Cascade. And then keep in mind, you can do the same thing with on update. So what actions do you want to perform when you update a specific user in that case? But we'll leave it as no action for now. I just mainly care about the on delete. At this point, that's all you have to do for foreign keys. You just specify the column of the other table it should point to, and you're good to go. We'll hit save. And then we're going to go under posts. Well, actually, before we do that, we're going to go under users. We're going to view all rows. And let me clear out some of these. There's too many windows open, right? And these columns got a little squished. But right now I have 3 users. It's got an ID of 17, 18, 19. So go ahead and remember that. Obviously, your database is going to be different. So just remember the IDs of a couple users. And what we're going to do is we're going to go under our posts and we're going to view edit. And so right now I have no posts because I deleted everything. So I'm going to create a brand new post and I'll just call this is my first post. And the content is just going to be some random content. I'll leave published blank because we've got a default value. And then right now, if you take a look, we've got this new user ID column. So if I try to save a post right now, take a look at what happens. It gives me an error. It says null value in column user ID violates not null constraint. So because we said that user ID cannot be null, we have to provide a user ID. So let's give it an ID. And if we go back to users, I can see that there's going to be, I can use 17, 18, or 19. So whatever user created this, I'll just say John created this. So we'll grab an ID of 17. And I'll say that this is going to be an ID of 17. And then if we save this, look at that. We now have a relationship between the users table and the post table. Let's create another entry. I'll call this second post. And it's going to have some random content. And I'll say that this was created by the user with an ID of 18. And that should work just fine. Now, what I'm going to do now is, what happens if I create a post and I give it an ID of a user that doesn't exist? So I have IDs of 17, 18, 19. What happens if I set the user ID column to be a value of 20? Well, let's try that out. So I'll just call this third post. And then we'll set the content to be something random. And if I set this to 20, let's see what happens. If I hit save, look at this. Insert or update on table post violates foreign key constraint. There's no user with an ID of 20, right? So that doesn't exist in that table, so it's going to throw an error. So that's the magic behind foreign keys, that it's going to check to make sure that that user actually exists. And so this isn't going to work, so we'll just set this to 17 as well. No, save that. Right? And that's it, guys. And when it comes to, kind of querying these users, right, let's go back to our database and let's just set up a query. Now, let's say I want to get all of the posts created by user 17. Well, we can do select star from posts where, and now instead of, searching for based off ID, we grab the user ID column and we set that equal to 17. So this is going to get me all of the posts that were created by user 17. If I run that, you can see that this got the 2 posts from user 17. And then if I change this to 18, we're going to get the 1 post created by user 18. So from a SQL perspective, right, nothing's really changed. You just specify what column you want to match on and then provide a condition. Now, what I'm going to do now is I'm actually going to delete this user. So I'm going to go and just say delete from users where ID equals 70. So we're going to delete John@Gmail. And we're going to actually do that here. So I'll say, first of all, select star from posts. All right, so we've got all 3 posts. And I'm going to run another query, except I'm going to say delete from users where ID equals 17. So what is going to happen when we delete those users, because we have posts that have relationships to them? Well, since we set the onDelete to cascade, it should delete these posts automatically for us. So I'm going to leave this down here, so it's going to run another query so we can see exactly what our table looks like after we delete this user. And so if I run this, you can see that when I run a select star from posts, there's only 1 entry left, and that's the one with the user ID of 18, because it automatically deleted all of the posts created with an ID of 17. All right, and so from a database perspective, I think this is all we really need to cover for now. Eventually, we'll start taking a look at joins, which is how to run these complex SQL commands that allow you to jam the columns of multiple tables into one result to make it a little bit easier to retrieve information. Because right now, if I try to get all of the posts, like send me every single post in my database, right? It's just going to give me the user ID. But if I need the information about the user, like what's the name of the user, what's the username or the email, then I would have to individually query the IDs of these users. So I'd have to go then, I'd have to do, a select, whoops, make sure I don't delete anything. I'd have to do a select star from users where ID equals 18. And I'd have to do this one by one for every single post so that I can get this specific user. And so that's when we start to make use of things like joins. But that's a little ahead of us at the moment, and that takes a little while to explain. So we're going to come back to that. But before we actually kind of move on from this database side of things, because we pretty much covered everything, we're going to delete that column for now, because we're going to make sure that SQL Alchemy actually sets up all of these constraints for us automatically so that we don't manually have to do it. So let's go to our properties, go to columns. We can just delete this column. And then I think this should automatically delete the foreign key. It does not delete the foreign key, so make sure you delete that as well. And then we can save that. And it looks like it's throwing an error. So let me cancel out of that. And I think we're going to have to do this in a 2-step process. So we'll say constraints, we'll delete the foreign key first. We'll save that. And then properties, we'll delete the user ID. There we go. And so now if I do a select star from posts, right, there should no longer be a user ID column. So this put our database back into the state it was in before we started playing around with it. So now that we know how to create and set up a foreign key within Postgres and pgadmin, we're going to see how we can do this through code using SQL Alchemy. Because ideally, since we're already using SQL Alchemy to generate all the tables, generate all the columns for each table and all the different properties, we should also set it up to generate the foreign key for us as well. So we're going to go to the models.py file. This is where we define what the tables are going to look like with the different classes. And we're going to add a new user ID or owner ID column to the post class. And that's going to create a specific column within the post table. And so we can just go here and, call it owner ID, user ID, whatever you want. I'm just going to call this owner ID. And this is going to be column. And then here we have to specify the data type of the column. And as I mentioned, the data type should match up with whatever the data type of the foreign key is. So since this column is going to point to the ID column of the user table, it should match up with whatever is here. So since this is integer, this has to be integer as well. Then to set up a foreign key constraint, you just type in foreign key and then go ahead and auto import that. If you don't know where it's getting imported from, it's going to get imported from SQL Alchemy. So if you didn't automatically do it, you can go ahead and just manually type that out. And then there's going to be two fields that we're going to pass in. So the first of all, we have to pass in the exact column and table and column that we want to reference. And so we want the users table and then grabbing the ID column. And so your instinct would be to use the class name, but we don't actually reference the class name. Instead, we want to reference the table name. So it's going to be lowercase in this case. So you say users dot, and then what's the column name? It's called ID. So we say dot ID. And then the second thing we need to do is, if you recall, we have to set up what the policy is for when we delete the foreign key or the parent table. And so we always used Cascade so that if the parent object gets deleted, all of the child objects get deleted as well. So we can do that through SQL Alchemy as well. And we'll say on delete equals, and then we just say Cascade. And then finally, we want this field to be nullable equals false. So it has to be filled in. All right. And now if we save this, restart our application, we'll take a look at Postgres. And if I actually refresh this, and this is actually an old panel, so I'm going to remove that. And then if I just do, we'll go to our post table, go to query tool. I'll say select star from posts. Run that. You can see that there is no actual owner ID column. And so the reason for this is that SQL Alchemy, when we start our application, SQL Alchemy will check to see if there's a table called posts. And if there is, if there isn't, it's going to then create a table based off of these rules. However, if there's already a table named posts, it's not going to do anything. So if we update any properties for a pre-existing table, it's not going to change that. That's not exactly what SQL Alchemy is meant for. Instead, we would have to use a database migration tool, kind of like Alembic, which we haven't covered yet. So instead, for now, what we're going to do is we have a couple of different options. We can manually just do it, go into pgadmin, add the things yourselves, or we can just take the easy way out. Since this is a development environment, we can just drop our post table. And that's one of the luxuries of working in development. So you can then hit save again, and that's going to cause it to restart the application. And then if we go to Postgres and we just hit refresh, it's going to create a new post table, and then we can go into properties and we'll go into columns. And we now see that we have an owner ID column, which is set to not null. That's good. And then if we go to constraints, foreign key, you'll see that we've got our foreign key, and you can take a look at the details down here. And the main thing I want to check is for actions, we do have on delete cascade. All right, and so now that we have everything set up, if I just run this query again, we should see the owner ID show up. So let's create a few entries. And before I do that, I need to make sure that I actually have some users because I kind of went in and deleted a few things. So I've got two users with an ID of 20 and 21. And so what we're going to do is we're going to make sure that the foreign key points to one of those IDs. So we'll grab a post. I'm going to just set this to be post1 as the title. And it's going to be some gibberish. And then we can set the owner ID to be the ID of a user that we already have in our database. We'll save this and we can see that it's successfully created. Now, if I create a new post, and this time leaving the owner ID blank, if I hit save, you can see that it throws an error because this can't be set to null. And if I try a ID of a user that doesn't exist, like 57, it should also throw an error. And so it's saying that, hey, the owner ID of 57 does not exist in the users table. And I'll just change this to 21, and then it should work. Great. Now let's quickly check out the on-delete functionality just to make sure that it works. And what we're going to do is let's go to, well, I'll just run the query right here. So we'll do delete from, and we'll say users where ID equals, and we're going to delete the user with an ID of 20. So if everything works, we should see just this entry also get deleted in the post table because the owner has an ID of 20. And since that owner is going to be deleted, then we should only have this one left. So if I run this, yep, we can see that the one with the owner ID of 20 is now deleted. All right, and so that kind of handles all of the database side of things. At this point, if you try to test the rest of your application, you're going to probably run into a couple of issues. But that's just because we've hard-coded our schema to match a certain number of properties. And so since we've added this new property to our posts, it's going to throw a few errors. So we're going to have to update a few things in the next video, but you'll see that updating your schema is very simple. With the changes we made in the last lecture, it's inevitably going to cause some issues with our application. So there's going to be a few things that we have to update within our app. And so let's just quickly run through a couple of our requests just to see what they look like, see what changes we need to make. And so if you haven't already done so, log in a user. And so once we're logged in, we should update the variable. And now we can retrieve our posts. So if I hit send here, you could say that we retrieve all of the posts in our application. I just have one in this case. But the first issue that I see is that we're not returning the owner ID. Right? This is a brand new column, and I would expect this information to get sent out to the user. And the reason why it's not included in here is that we have to actually update our schema, because our schema probably doesn't have that owner ID because we never added that in. And you might be thinking, well, do we actually need to send it? Yeah, I think it makes sense for us to send it because in any application, the user should know who creates a post. So ultimately, they're going to have to get that information. And so we should provide the owner ID. So let's go to our code. And if you actually go to the posts router and take a look at the get all posts, you'll see that the response model is going to reference schemas.post. So let's go to schemas.post. And you can see that this is what we're using to return. This is the schema that we're going to use for returning posts to a user. And so this actually inherits from Postbase. So Postbase has title, content, published. And then we extend that and we're going to add the ID, which gets created at the database level, as well as the date and time, or the created at field, which gets added by the database. So we can add it here. However, I'm sure you're thinking, well, could we add it at Postbase? Should we add it at PostCreate? Well, let's think about this. Right, the first thing that we have to think about is when we create a post, should we be passing in a owner ID? Well, that we 100% absolutely could do that. And that actually does kind of make sense. So in that case, if we did want it to be available or require it for creating a post, then we would add it under post create here as well. Or we could just add it under Postbase so that both of them inherit it. However, what we're going to do is we're actually not going to require the user to provide the owner ID. Instead, what we're actually going to do is we're going to let the logic of our route to actually just grab the ID from the token and then use that as the field. So we don't actually need the user to pass that into the body. So we're not going to use that field or apply that field to either one of these classes. We're just going to do it for the post class, which is the one that's responsible for sending the post out. So I'll add a column here and we'll call it owner ID. And I'm going to say that this is going to be a type of int. All right, let's save that and let's see if that makes a difference. So let's hit send. And so now we can see that we get the owner ID. And that's really all the changes we have to make. So if we actually go to get one post and we look at our code here, and if you look at the post.py, for getting an individual post, you can see that we're returning the same exact model. And if we take a look at creating a post, we return the same model. So all of those will be updated accordingly. And same thing with the update post. The update post also uses schemas.post. So since we're using the same schema for all of them, we don't have to do anything else. And we could just quickly test that out. So I'll do get one post. And I realized we have to actually get, what was the ID? ID is 4. So we're going to update this to be an ID of 4. You can see that we now have the owner ID there. If we update it, right, we can once again get the owner ID. And at that point, it looks like everything else is good. However, if we go to create posts real quick, and we create a post, right, we get a crash actually. So there is an issue with creating a post, and I'm sure you guys can guess exactly what it is. Take a look at the error when we try to create a post. Right, it's saying there's some kind of SQL error, and it says there's a null value in column owner ID. And that makes sense. So we'll actually tackle this in the next video, and you'll see that it's going to be pretty straightforward to actually get that resolved. So in the last video, we learned that the create post functionality is broken now, because if I try to create a post, you can see that it sends back a 500 status code. And if we take a look at the logs, we can see that it looks like there's some issue with the SQL, and it's saying that the null value in column owner ID violates the not null constraint. And so looking at our model, we obviously set the owner ID right here. And this is set to be nullable false. So we actually have to provide who the owner ID is for this new post. So how do we do that? Well, let's go to our post path operation, and let's go to the create post path operation. And so it's right here. And so nowhere in this code are we actually providing a user ID or owner ID into this new post that we're creating. We're just grabbing the post, which comes from post create, the schema. And if we look at that schema, you can see that we do not provide a owner ID. And like I said, we're not going to actually pass the owner ID in the body. What we're going to do is whoever is logged in and creating the post should automatically be the owner, right? If you're logged into Twitter and you post something, Twitter knows that you're the one creating the post. So whatever ID is associated with your account, it's going to set that automatically. So we shouldn't have to pass that in the body. We should automatically retrieve it from your authentication status. So within post, right, you can see that we have the current user. And so we should be able to get the current user or the user's ID. So if I do current _ user.id, and we can remove this, I don't need the email. And if I try to create a post, it's still going to error out. That's okay. I just want to see what it prints out though before the error. And you can see we got a lot of errors. That's okay. And you can see that it printed out the ID of my user, which is 23. And just to double check that that's actually my user, I'm going to select star from users. And you can see that 23 is Sanjeev@gmail. So we could just take that and just add that into the new post object. And so we're creating the new post right here where we reference models.post. And what we're doing is we're just spreading out the schema that we got from the body. And so to actually add the ID property, it's very easy. All we have to do is just say owner _ ID is going to be set to current _ user.id. So we're just grabbing that from the get current user function, just like we did right here. And I think we probably need a comma there. And that should be all that we have to do. So I'm going to remove this code. And let's test this out now. So if I do create post, look at that. No errors. You can see that the owner ID was automatically set to the ID of my user, which is 23. Currently in our application, we do have authentication set up for delete post and update post. However, there's no check to make sure that a user is only deleting his own posts. Right now, if you're logged in, you can delete anyone's posts. And no application works like that. You should only be able to delete your own post. No user should be able to come in and delete one of my posts. That doesn't make sense. So let's implement the logic for setting up a quick little just if statement just to check, hey, is the person that's logged in trying to delete a post that he owns? If he doesn't, then we're going to return an error. And so right now, if you take a look at our delete post path operation function, we query the post that he's trying to delete, and we check to see if there's no post. If there's no post, then we send a 404, that's expected. But if we did find a post, the next check is just going to be another simple if statement. And we're going to say if post.owner underscore ID does not equal get current user dot ID. So these two things have to match for the user to be able to delete it. If they don't match, then we're going to send another HTTP exception. So we'll say raise HTTP exception. Now the exception, we'll set the status code to be a new one. So this one's going to be a 403. So this means forbidden. That means it's a resource that they specifically aren't able to access, because we could send a 401, but they are, I guess a 401 could also work, but I'm going to do 403. I think that makes more sense. And then we can set the detail. And I'm just going to say not authorized to perform requested action. And this exact same check can be used for updating posts as well, because it's the same exact logic. And I'll just do that right here, right under the same check. So same logic, right? First thing we're going to do is we're going to check to see if that post exists. And then the next thing we're going to do is we're going to make sure that the owner of the post is whoever the user is logged in as. Now let's test this out. So right now, if I do a get posts, you can see that the owner, okay, so we've got a post created by both owners. And I'm currently logged in as, I actually can't remember who I'm logged in as, but we can see that I used Sanjeev at Gmail, and that's going to be user 23. And what I'm going to do is go back to get posts, and I'm going to try to delete the post with an ID of 4, because that's the owner ID of 21. And keep in mind, right now I'm logged in as user 23. So let's try this. We're going to delete post with an ID of 4. Okay, it's already set there. So we should get an error in this case. And it looks like I got a server error. That's a problem. And I already see the issue. And right now, post is actually not the post itself, it's the query. And to actually get a post, I have to do post.first1. So what I'm going to do actually is I could change this to post.first and then grab the owner ID, but I'm going to actually perform the query right here. I'll say post. Actually, I'll change this to post underscore query. I'm going to make a few changes actually. And I'm going to set this to be post equals post underscore query dot first. And then I'm going to set this to be post. And this is going to be set to query. All right, and just to kind of quickly recap, we define the query here. We'll then find this post. We'll check to see if it's not there. And then we'll check to see if the owner is, if the user who's logged in actually owns this post. And then we're going to grab the original query, and then we're just going to append a delete so that we delete it. That's all. And let's just make sure the update is set up the same way. And it looks like the update one was already working that way, so it should be good to go now. Hopefully there's no errors. And let's try this. And once again, we got an error. And it looks like function object has no attribute ID. And I realized my mistake again. First of all, this is getting stored as current user, not get current user. So we need to change this to be current user. I'm not sure why I did it like that. It seems pretty goofy. And then this also should be current user, right? Because we're calling that function and we're storing the result in current user. So we want to reference the variable. I'm not sure if that was like an autocomplete that did that, or I just had a brain fart. Either way, hopefully it's the last of our issues. So let's try this. All right, perfect. Look at that. Not authorized to perform that requested action. That's to be expected because we don't own that post. However, if I do a quick search again, I do own the post with an ID of 8 because we can see the owner ID is 23 and that's who I'm logged in as. So let's try to delete post with the value of 8. Send. And we get a 204, so that means it's successfully deleted. We'll do get post just to verify. And we can see that we get those, just the one post now. So that seems to be working. I'm going to go back in. Actually, let me create a post real quick because I no longer have a post. All right, so we created a new post. And so you can see that this is my post right here. And I'm going to just update it. So let's go to the update one. First of all, I'm going to try to update a post that I don't own. So we're going to try to update the post with an ID of 4. We should get a not authorized. And then let's grab the ID of the post that we do want to change, which is 9. Let's hit send. And it looks like it updated, but let's check our database always. So we'll say select star from posts. And the post with the 9 got the updated entry. Oh, wait a minute. It looks like it may have updated both of them. Only one way to find out if that's actually what's happening. I'm just going to create a quick new post. I'm just going to set the ID to be 23. All right. And I'm going to update post with 9 with an ID of 9. Okay. And then let's refresh this. Okay. So post with an ID of 10 is still the same. So, okay. It wasn't a bug. It looks like maybe I had changed this earlier. And I'm not exactly sure when I updated this post, but that's okay. And so I think that's going to wrap up this video. We've handled the update and delete so that we can only update and delete our own posts. All right, before we proceed any further, I do want to talk about one last thing. And that is that when we do get posts, which is an authenticated route, so it requires you to be logged in to retrieve the posts. If I try to retrieve the post, you'll see I get posts from every user. Now, this may or may not be the result that you want, right? It's going to depend on what your application is going to look like. If this is like a note-taking app or something where all of your posts and things like that are all private, then you wouldn't want to return everyone else's posts. You'd only want to return the user's specific post. However, if this is some kind of social media app, right, then obviously your posts are public. So when you do get posts, you would want to return everyone's posts. And so it really just comes down to how you want your app to function. I'm going to show you guys what you would need to change if you wanted to make it so that you returned only your own posts. But afterwards, we're going to actually delete those changes because I want to leave my app like this. This is kind of how I wanted it to work, more like a social media app. But I do want to make sure that you guys understood how to make this change. And the same thing would go for get one post. We want to make sure that only the user that created a post can retrieve that specific post. And so if we go back to our path operation for getting all posts, you could see that we just do a db.query.all. And so if you only want to return the posts for a specific user that's logged in, it's very simple. All we have to do is do a filter. And here we'll say models.post.id equals, and then we just get the current user's ID. And it looks like I still left this as user ID, so this should actually be updated to be current_user. And if you notice, you can see that the type is set to int, even though it's actually returning an entire user object. I found that whatever type you put here doesn't actually impact the code. So put whatever you want. You can put in some sort of dictionary that actually correctly matches it, but you could just leave it as well. So I'm just going to leave it like that. It doesn't break any logic. And then at this point, I believe I'm still logged in as user 23. If I try to retrieve all posts, looks like I got nothing. And that could be a little bit of a problem. So let's see what we broke. And the easiest way to kind of troubleshoot this is what I'm going to do is I'm actually going to remove the .all. So that's going to return the query. It just won't actually run the query. And I'm just going to print the query. Let's see what that looks like. Sometimes it helps to see the raw SQL. So let's hit send. All right, we should get an internal server error. That's to be expected. But I just want to see my print statement. All right, so let's see our print statement. So select, we're getting all of the columns. That's expected from posts where posts ID equals this value. So that looks like it's perfect. Well, let's just quickly see before we move any further, what exactly is my user ID? And we'll just check our database. Okay, and we'll run this again. And then we're going to check. All right, so 23. And then if we go to our database, and I realized the exact mistake that I made, and this is a stupid mistake, right? This is looking for a post with an ID, with this specific ID. We don't want the ID of the post. We want the owner ID. So we'll do owner_ID equals current user ID. All right, let's test this out now. Once again, an error, but I just realized I forgot to update this to be .all. And then we'll try this again.
And now we get all the posts with an ID of 23. If I log in as a different user, let's say this is Sanjeev1, I'll log in. That should update the token. So now if I do a get all posts, it should return all posts with an ID of 21. And so that's how that works. And then if you want to see how that looks like for retrieving an individual post, we'll go to get underscore post. And to actually handle this logic, it's going to be the same thing as a delete. So you can just copy what we did for the delete one. And here I can just say post.owner. And this should do the same exact thing. So now if I do get one post, well, first of all, let's take a look at all of our posts. Actually, I'm going to do it in our database. So I'm logged in as user 21. So I should be able to access a post with 4, but I can't access a post with an ID of 10. So let's try 10. Am I able to access him? Not authorized. Let's try ID of 4. And I can get that one. So that's how that works. But like I said, I don't want my application to work like that. So I'm going to remove that functionality. I'm going to make all posts essentially public. And then we're going to remove this filter. And I'll remove this print statement and this print statement just to clean things up a bit. And let's just double check that we didn't break anything once again. So let's get all posts. We get all posts. And let's get an individual post, regardless of who owns it. And that's all fine and dandy now. Now, just kind of thinking ahead of what our front end would look like, even though we're not going to build it, taking a look at any social media type application, when we retrieve the posts, we usually want to embed the user's ID. So we want to know who actually created the specific post. We wouldn't just put the owner ID because none of your users understand that ID. They want to see what is your Twitter handle, what is your email, whoever created that. We want to see their user ID. So it looks like for all of the posts that we retrieve, we would have to then send a second query to retrieve, hey, what is the information for user with an ID of 23? And then once we get that, we would then have to kind of combine all that data so that we can figure out what post it belongs to what user and what is their specific username. Now with SQL Alchemy, we can kind of set it up so that it automatically does this for us. And so if we actually go to our models, what I'm going to do is I'm going to set up a relationship. And so this relationship isn't a foreign key. It does nothing in the database whatsoever. But what it does is it'll tell SQL Alchemy to automatically fetch some piece of information based off of the relationship. And so here I could say, we'll create a owner. And I'm going to say owner equals relationship. And we probably have to import this. And so it did. So it imported relationship from SQLAlchemy.orm. And so if you haven't done that, go ahead and do that. And what we'll say is, this is going to return the class of another model. So here I want to return the user. And this is going to be a capital U because I'm not referencing the table. I'm referencing the actual SQL Alchemy class. So what this is going to do for us automatically is that it's going to create another property for our post so that when we retrieve a post, it's going to return a owner property. And what it's going to do is it's going to figure out the relationship to user. So it's going to actually fetch the user based off of the owner ID and return that for us. And there's nothing else we have to do. It actually is that simple. This is one of the great parts about SQL Alchemy is that these relationships will automatically make it so that it fetches that data for us so that we don't have to manually do it ourselves. So let's test this out. Let's see if this actually works. I'm going to go back and I'm going to retrieve all posts. And it looks like nothing's changed. We don't get any user information. We do, once again, just get the owner ID. So what happened? Well, you probably can guess we need to update our schema. And so if we go to our post, we're now going to return a user. And so here, what we would do is we would just add another property called owner. And then here it would, instead of returning an int or a string or anything like that, we can actually return a Pydantic model. So I can say, I want you to return a user. Whoops, a user, but it looks like we don't have a user class. We have user out, and then we have user create. So which one do we actually want to return? Probably user out, because that's what we're returning. The user create is for creating a user. And you notice that we get an error actually here. And that's because this user out hasn't been defined at this point in the code. So you have to read Python top down. And so user out is actually defined all the way down here. So if you wanted this to work, we would have to move all of the user stuff up a level. So I'm going to cut this and I'm going to just put it right above post. And so this should remove the error. And so now it looks like it's good. And so once again, all we did was we added a new property called owner, and this is going to return a Pydantic model type called user out. And so that's all this is returning now. So let's see if this fixes our issue. And now I'm going to retrieve all posts. And so now take a look at this. It automatically fetched the owner. It got the ID, it got the email, it got when their account was created at. We may not want that, but for now, I think this makes sense. We could create another class to kind of narrow down the exact fields that we specifically wanted for this situation, but I think this is good enough. These are all the informations that I want actually returned. So this is perfect. It's going to do this for every post. And if I try to get one post, it's also going to return that specific owner. And so in reality, to get this functionality, right, once again, all we had to do was just create this relationship. And so once SQL Alchemy understands the relationship, it's going to fetch that piece of information for you from the user model. In this lesson, we're going to take a look at query parameters. And if you've never worked with an API, you may not know what that is, but I guarantee you, you have worked with them before and you have seen them. You just had no idea what they were. And so I'm on Yelp.com and I'm just doing this for demonstration purposes, but I'm just going to do a quick search here. I've just picked a random city. In this case, it's Miami. We're going to search for that. And I want you to take a look at the URL. And so our URL is, first of all, we have the domain name, which is kind of like the IP address. And then we have the specific endpoint that we want to reach. So this is the /search endpoint. And so in their API, they've set up, some sort of endpoint that probably is allows you to search for restaurants. And then we have a question mark. And I know you guys have seen this before because pretty much any website you've ever used, you'll see that question mark whenever you're searching for things. And any results you get, you'll see that in the URL. And so everything to the right of that is what's referred to as query parameters. So all of this is query parameters. And a query parameter is a optional key value pair that appears to the right of the question mark. And these query parameters allow us to kind of filter the results of a request. So, if we're trying to retrieve posts, maybe we don't want all posts. Maybe we want to get posts that were created in the last 2 hours. Maybe we want to get posts that, if it's a social media type app, maybe we want to get posts that have received over 100 likes, right? These are all things that you would do using query parameters where you can say, hey, you could just pass in a key and a pair, and you can say, I want to find posts, that are less than 2 hours old. And so a lot of other operations that are necessary in an API, things like pagination, those are all going to be done with query parameters. And if you take a look at this one, since we searched for Miami, right, it looks like it passed a query parameter called find_loc, which probably means location. And then it says Miami, Florida. And so it's going to basically talk to the API and say, hey, listen, I need you to get me all the restaurants, and I want you to filter down based off of restaurants in Miami. And so that's kind of how query parameters work. And so for us, it's up to us to define what query parameters we want to allow and what we want them to do. And it's going to vary from app to app, but you'll see that most APIs have a couple of query parameters that they all use. So let's go to our app real quick. And what we're going to do is we're going to go to our post router. And in this case, we've got our path operation of retrieving all posts. And what I want to do is I want to let the user be able to kind of filter down on the posts that they want to see. And the first thing that I'm going to do is I'm actually going to allow them to specify how many posts they want to retrieve altogether. So I want to give them the option to say, hey, I want 10 posts, or maybe I want 100 posts, or maybe I want 50 posts. We should allow the user to define that. And so to allow a query parameter, we could just go into our path operation function and just pass in another argument. So I'm going to do question mark. Then we give it the name of the query parameter. So this is the key essentially. And I'm going to call this limit. So this is going to limit the number of posts they get. And this is going to be of type int. And we're going to give it a default value. So we'll say that, by default, if they don't provide a limit, we're going to say the limit by default is 10. And now all I'm going to do is I'm going to print out limit. All right. And I'll show you guys how to actually send that query parameter. So let's go to our get all posts. And so to send a query parameter, it's very easy. You just type in a question mark. Then you grab the name of the query parameter, which once again is limit. So we'll grab limit. And then you say you set it equal to whatever value you want it to be. So if I want to get a limit of 3, if I hit send, right, nothing should have changed in our code, but you can see that we were able to print out the limit. So that's how we access query parameters in FastAPI. It's pretty simple. You just pass it in as another argument into your path operation function. But let's actually set up our query so that it now takes into account the limit. And with SQL Alchemy, anytime you want to, perform another operation, you usually have a built-in method. So I'm going to remove this .all for now. And so if I want to limit the number of results, I just do dot, and then let's see what methods we have at our disposal. Since we're looking for something that limits something, let's maybe check to see if there is a limit method. And looks like I don't see one here, but there actually is. We can do limit, and then here I'm just going to pass in the limit variable. And then after that, we can just do the .all as we usually do. All right, and so now, well, first of all, in our database, we don't actually have that many posts. So I'm just going to create a couple. Well, actually, I could just do this through our API a lot quicker. So I'm just going to create a whole bunch of posts. And so that should give us 5 posts. Well, let's create a few more. All right, so we've got 11 posts now. And we'll go back to our API and we'll say, I want a limit of 3. So let's send that. And let's see if we only get 3 posts. So we get 1, 2, 3. Perfect. And if I don't provide a limit, well, actually, let's try a different number. Let's try 5 now. All right, we get 1, 2, 3, 4, 5. Perfect. And if we don't provide a limit altogether, it should return 10 because our default was set to 10 posts, so limit of 10. And so we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there are 11 results, so there's one result that it didn't provide. So we've got the limit functionality down. What I want to do now is allow the user to skip results. So it grabbed, depending on however Postgres has decided to return 10 posts, it grabbed the first 10 based off of some criteria. And if we actually take a look at how it did, it looks like we got ID of 10, ID of 4. So it's kind of just all over the place. So it's probably not sorting based off of any specific field. We may want to specify that. But what we're going to do is I'm going to actually set the limit equal to 2. And so we'll get the first 2. However, Postgres determines what are the first 2 it should send, we get 2. But let's say we want to skip over a couple of them. Maybe we want to skip the first 2. Maybe we want to skip these 2. Well, I want to be able to send another query parameter called skip so that we can specify how many we want to skip. And if you want to send more than one query parameter, we just do the and keyword, and then we provide the next key value pair. So it would be like skip equals 2. And so just taking a look at the IDs here, we've got one with an ID of 10 and one with an ID of 4, and we want to skip both of those. So going back to our code, we're going to provide another path operation function, another argument into the function, and we'll call this skip. This is going to be of integer, and the default is going to be, let's say 0. We don't want to skip anything by default. And to add this to our query, we use the keyword offset. So we do offset. And then here I'm going to say offset equals skip. All right, and so we should be able to skip over both of these. And so if I provide a skip of 2, you can see it first starts out at 9 and then 11. If we do skip 0, right, it shouldn't skip any, right? 10 and then an ID of 4. If we skip 1, it should just skip the 10 and then start off on 4. And we can see that the first one is 4. So it allows us to skip over posts. And so that's ultimately how we're going to implement pagination on the front end, is because the front end should be able to skip based off of what page they're on. So if each page returns 20 results and you want to go to page 2, then you want to skip 20 results. If you want to go to page 3, you would skip 40 results. Now, the last query parameter I want to set up is a search functionality. I want the user to be able to search based off of some keywords in the title or maybe even the content, depending on how we want to implement searching. For now, we're just going to say we'll be able to search based off of the title. And the way that the search will work is we'll have another and we'll say search equals and then some random text. And so once again, we're going to provide another argument called search. And this is going to be of type string. However, this is, we can't exactly give a default search. So I'm going to say this is optional. It's going to be an optional string. So we don't have to provide this. And the default is just an empty quotes. And it looks like I have to import optional from FastAPI or from typing. And so here I'll just say import optional. And this is going to give us an optional query parameter. And so what we're going to do here is I'll say filter. And to filter this, and just kind of like how we filtered based off of a specific user ID or a specific post ID, I can say models.post.title. And then we can use a method called contains. So we can say contains and then the search keyword. So this will allow us to provide some kind of string and it'll just search for the entire title of a post and it'll see if the search keywords are anywhere in the post title. It doesn't have to match completely. It just has to be somewhere in the post. So this will give us a little bit of flexibility so that we don't have to match the exact name of the post. We could just provide some keywords like hot dogs or beaches or whatever, and it should be able to just see if it's contained in there. So let's take a look at our database. You can see that we've got a lot of ones that say top beaches in Florida. So I'm just going to do a search. And if I just search for beaches, it should return all of these because they all contain the word beaches. And I'm just going to do a search and I'll get rid of the limits and the skip for now. We don't really need that. And all of the results should be, actually, I don't think I saved it. Let me save that. And now if I do this, you can see that every result is going to have the word beaches in the title. And when it comes to query parameters, you can string as many as you want. So if you wanted the limit as well, and we'll set the limit to 2, and we can also provide a skip equals 1. You can add as many of the query parameters that you want. So now you can see that we set the limit to 2 and we skip the first one. Now, the last thing I want to show you guys is how to use spaces in your search query. Because right now we just have the word beaches, but let's say I wanted, just going into our Postgres database, let's see what I've got. Maybe I want to search for beaches, hello, or something beaches, right? How would I search for that in a URL? I can't put a space in the URL. I can't say, something beaches. So how do I do a space? Well, I can do % and 20, which is which means space in your URL. And then you can do beaches. So then just to verify that that's actually returning what we want, I'm going to do a print and we're going to print out the search keyword. And we're going to test this out. So if I hit send, you can see that it returned the one result that has the word something and then beaches, but it doesn't return anything else. What I would like to do now is do a little bit of cleanup on our main.py file. You'll see that there's a lot of unnecessary imports that we don't need, especially since we moved all of our routes into their respective folders. So you'll see that a lot of these are grayed out. And so anything that's grayed out, we can move. But before we actually do that, what I actually want to do first is I want to take this code for connecting to our database using the regular Postgres driver. I'm going to move that to our database.py file. And keep in mind, we could just delete this because we're no longer using this. And we're using SQL Alchemy to actually connect to our database. So you can actually delete this. But just for documentation purposes, I'm actually going to just cut this out. And I'm going to move this into our database.py file. Just so that you guys have this for reference in case you ever want to run raw SQL directly using this Postgres library. instead of using SQL Alchemy. I want to make sure this course covers as many different, possible situations for you guys. But moving this here, obviously we're going to get some errors because we have to import all of these. And I'm just going to go to our main and I'm going to import them from here. So here, I'll just copy these two. And we'll actually just cut it out. And then it looks like we also need time. Where is that coming from? It's just coming from the time. Okay. All right, that should remove any errors. And we can just comment this out actually, because we're not going to use that anymore. And then going back to our main, you can see that both of these are grayed out. So we're not even importing anything from typing anymore, or we're not using anything from typing. So I'm going to remove that. You can see that we're no longer using status. So we're no longer using all of these. So I can remove all of those. And I'm not using the body here anymore. I'm not using anything from Pydantic. And I'm not using anything from random. We'll just get that a little bit closer. We're not using session anymore either, so I'll remove that. This, whatever that is, I'm going to remove that. And then we'll remove schemas and utils. We can remove getDB as well. And then obviously the posts array or list, that's no longer needed. These two functions, they're no longer needed. They were before we started working with databases. And then, we don't actually need this route anymore, but I'll just leave that in there. But you can see that our code is a lot cleaner now after removing all of those unnecessary imports. I'm just going to structure this a little bit better so all the code's a little bit closer together. And I think that's all the cleanup that we need to do for now. I just wanted to make sure there wasn't too much garbage building up in our application. When we first started working on databases, I mentioned that we should never hard code our database information or the database URL into our code, because this creates two issues. First of all, we're exposing our username and password right there in code. So anyone can see it. If we check it into GitHub, anyone who has access to it can see our password now. And at that point, we've compromised our application. But on top of that, the other big issue is that right now we've set this URL to go to our development Postgres instance, which is running on our local machine. When we actually deploy this to production, our Postgres server is not going to be running on this machine. It may not even be running on the machine that our application is actually deployed on. It could be on a completely different system. So we would need a way for the code to automatically update in a production environment to point to the actual production Postgres database instead of using the one that's hard-coded in here. And so we need a way to do that. And keep in mind, this isn't exclusive to just working with the databases. Any kind of confidential information, any passwords, secrets, anything that needs to get updated based off of the environment that it's in needs a way. We'll run into this same exact issue. Right? And if we go to our OAuth2.file, you can see that we have our secret key hard-coded in here. This is something that we don't want to do. We don't want to expose this, and we need this to get updated between our development and our production environment because they may not be the same on both. So how do we do that? Well, we're going to make use of something called environment variables. And so an environment variable is just a variable that you configure on a computer. Doesn't matter what operating system, they all support it. And when you configure an environment variable on your computer, any application that's running on that computer will be able to access it. And that includes our Fast API. So your Python app will be able to access any environment variables on the machine. And so instead of hard coding the values in our code, what we'll say is, hey, retrieve an environment variable named, whatever. Like we might have an environment variable called Postgres_URL, and that's going to contain the URL of our Postgres database. And so we don't need to hard code the actual value. We hard code just the name of the variable, and then Python will automatically pull in that variable. So let me show you guys how to do that. And I'm going to show you guys how to do this on Windows first, and then we'll take a look at this on a Mac or a Linux machine. Mac and Linux are the same steps. So I'm going to search for environment, and you'll see this edit the system environment variables. And what we want to do is we want to go to environment variables under the advanced tab. And here you'll see two sections. You've got system variables. This is going to be environment variables that are system wide, which means any user can access them. And then we have user specific variables. So these are variables that only I can access. And you can just kind of, go through these and just take a look at them. But you can see that we have an environment variable called path. Don't worry about what it's used for. This is something that gets set up when you install your machine. But we're going to take a look and try to access this. So you can see that this is the key, the variable name path, and then the value is some sort of path in our operating system or in our file system. So how do we actually access that? Well, let's open up a terminal. And here I'm just going to type in echo. And then we want to access an environment variable, just do % and then the name of the variable. So I'll say path with a capital P. And if I run this, you can see that it prints out that specific path. And so that's how you access an environment variable on the command line. With Python code, it's going to be a little bit different, but it's still pretty simple. I'm going to open up a new file just for demonstration purposes. You don't have to actually follow along on this. And to actually access a environment variable, we have to import the OS module. And then to access that variable, you say os dot get nv. And then within this method, you just pass in the name or the key of the variable. So in this case, it's path. And I'm just going to store this in a variable, and we can call this anything. I'll just call this path. Why not? And then I'll print out path so we can see if it actually works. So now if I do pi-3 and then run example.py, you can see that it printed out that same exact path. Now to set a new environment variable, we would go to new. And maybe I create a URL, a variable name called Postgres. Or we can just call this, how about my_db _URL. So this is going to have the URL to access our database. So I'm going to say this is at localhost :5432. I think that's what our database is running on. And I'll hit OK. And so here we can see that this is our new environment variable that we created, my_db_URL, and it's set to localhost 5432. I'll hit OK. And then I'll hit OK here. And then what we're going to do is we're going to try to access that variable. So I'll do echo my_db_URL %. And actually it should be %%. And you can see that it does not print out what we said. It just prints out exactly what we wrote. So what gives? What happened here? Well, anytime you set a new environment variable, what you got to do is you got to close out your terminal and open up a brand new one. So I can close this out, or I can just open up a new one. And this new terminal, well, actually, I don't want a PowerShell. I want a command prompt. So this new terminal will be able to access newly created environment variables because they get set as soon as the terminal opens. So once the terminal's open, I can't change them. So I have to open up a new one so that it can reread and import all of those environment variables. So now if I do echo %my_db_URL %, it looks like I may have mistyped this. So hold on, let me see what it's called. And that looks like it's correct. So what's happening? Well, I'm going to close out all of them. That's probably what's the issue. So let me open up a new terminal. And I'll open up a new command prompt. And now I'm going to try echo %my_db_URL. And now we can see that we can read it. So we have to close out our terminals and open up a brand new one. It's kind of annoying, but that's just the way it works. Now, on top of that, there's an even bigger issue, and I think this is exclusive to Windows. And that is that VS Code, the terminals here, it's whenever you set a new environment variable, they never have access to it. So you could try deleting all of these terminals and then creating a new terminal and then accessing that new environment variable, my_db_URL. And if I try to run this code, you'll see that it just says none. And if I just try to run the same echo command here, you'll see that it just spits it out. So it's not able to read it, and it's a little bit of an annoying issue with VS Code and Windows. You have to close out every single VS Code window that you have and then reopen them. And sometimes even then that doesn't fix the issue. So know that this is just kind of a limitation with Windows. But ultimately, don't worry too much about that because you're going to see that, especially in a development environment, going into and actually setting all of these variables yourself is unnecessary, right? I don't want to have to go in and set one for my database IP, my database port, as well as my secret key, my password, my username. It's just too many to manage yourself. And you'll see that more complex applications could have 10, 20, 30 environment variables that need to be set. So instead of going into your system and actually changing it, I'm going to show you guys in the next video. I'm going to show you guys how we can get around this by using what's referred to as an environment file. And so you don't actually need to worry about the limitations we're running here because we're never actually going to set our own environment variables on our local machine, especially in our development machine, because it's just too slow of a process and it makes things unnecessarily difficult to troubleshoot. So before we wrap things up, if you want to delete that environment variable, feel free to do that, which we can just go here and I can just select that and then hit delete. And let me show you guys how to do this on a Mac. To set an environment variable on a Mac machine, the command that we run in the terminal, there isn't a GUI kind of like in Windows. We actually have to use a terminal, which I actually prefer. What we do is we just type in the command export, and then we provide the name of the variable or the key. So I'll say my _db _URL. Then we say equals, and then we just provide the text, the value. So in this case, maybe this is localhost 5432. All right, and then to actually read the environment variables that have been set, you type in print nv. And here we can take a look at all the environment variables. Most of these have been set by the machine itself. And you'll see that nowhere in here do we see, well, actually we do see my DB URL right here. However, just like I said in Windows, sometimes, depending on the terminal you're using and a few other things, sometimes you actually have to close out this terminal and open up a new one to actually get the new environment variable. But here we can just access it by typing echo, and then we could just say $my_db_URL. And you can see it prints it out. And then within Python, just like we did on the Windows machine, accessing it is the same exact way. It shouldn't matter which operating system you're on. It's the same exact thing from your code's perspective. With any project, there's going to be a certain number of environment variables. And as I said, as your project grows, you're going to have more and more of them. And one of the issues that you can run into is that you could potentially forget to set one of them, either on your development environment or your production environment, and it's probably going to cause your application to crash. And so what would be good is to perform some sort of validation to ensure that all of the right environment variables have been set for your application to actually run properly. And on top of that, it's important to understand that when you read an environment variable, it's always going to come out as a string, which is fine, but it just means that you have to do all of the validation in code. So if you're setting an environment variable for your access token expire minutes, right? We needed this to be an int, not a string. But when we read the environment variable, it's going to come out as a string. So we have to convert this to an integer. So when it comes to verifying that all of the properties are set, as well as performing validation, we might have already kind of addressed this issue with a different part of our application. Right? And that's our schemas, right? We do the same thing with all of the data we send in the body by using Pydantic to perform all of that verification to make sure that every single property that we need is there, and to also perform all of the typecasting. So if we set it something to be an integer, it'll automatically convert it and validate it that it is a valid integer. And what's great about Pydantic is we can actually use Pydantic to perform all of that validation for our environment variables. And let's see how we can actually do that. So I'm going to go to main.py, and as an example, I'm just going to import from the Pydantic library something called base settings. And so just like with any other Pydantic model, right, we can set up a class, and I'm going to call this settings, and this is going to extend base settings. And I didn't mean to accidentally import base. And here we can basically just provide a list of all of the environment variables that we need set as properties on the class itself. And so, maybe I need something called database _password. And this needs to be of type string. And we can even give it a default value, which is localhost. And then maybe I need a database username, which is going to be string. And we can give it, once again, a default password. We don't actually have to give it a default value, but if you want to, you can. And I'll say this is going to be Postgres. And then maybe we want the secret key. And this is once again going to be a type string, and we can just give it, some arbitrary default. And let's say these are the only environment variables that we need for our application to run. By setting it like this, it's going to automatically perform all of the validation for us to ensure that all of these have been set. And an important thing to understand is that when you set environment variables, if we just quickly go back to the environment variables on my machine, normally best practice for environment variables is to do all caps with underscores, right? It doesn't have to be all caps, but this is just kind of standard convention. You can see I've got some that aren't like that, but in general, you want to do it all caps. And you can see here, we reference it all in lowercase. So Pydantic will automatically handle all of this from a case insensitive perspective. So it doesn't matter if you capitalize this or lowercase everything. It'll take all of your environment variables and it'll convert it to lowercase just to simplify everything. Then we create a variable called settings equals, and then we say settings. So right here, all we're doing is we're creating an instance of this settings class. And so at this point, Pydantic will read all of these environment variables. And once again, it'll look for them from a case insensitive perspective. So it doesn't matter if they're capitalized or not. And then it's going to perform all of the validation. It's going to ensure that they're properly a string and so on. And then finally, it's going to store it in a variable called settings. So then we can access all of these variables by just saying settings dot and then the name of the property. So if I want to get the database password, I just do settings.database password. And so we can print this out. And I'll just start my application. Right? And you can see that it printed out localhost. And if I want to grab maybe the username, I just say username. Actually, sorry, it should be database underscore username. And you can see it prints out Postgres, which is the default values because I haven't actually set my system environment variables to be any of these values. So it's going to use the default one. And like I said, we're going to run into that Windows issue where I can't exactly update it without closing everything. So I'm not going to bother doing that. But what I will do, just to show you how this validation works, is let's remove this. Let's say there's no default password. And so if there's no default password, then it's first going to check my system, my system or user environment variables to see if there's something called database password. And since I didn't provide a default one, if there is no environment variable with that name, it's going to throw an error because the whole point of this is to validate that all of the environment variables that we have are configured here. And so after I save it, if we take a look at this, you can see that we get one validation error for settings. So settings, database password, and we can see that it's missing. Right? And so having that quick check makes our life so much easier so that we don't have to figure out, which environment variable is missing, which one's not. Because like I said, you could have 10, 20, 30, 40 of them. There's going to be a lot of them. And managing them does become a little bit of a challenge. Now, one quick thing, let's say I go to my environment variables once more, and I've got something called path, right? So path is, the path to a specific directory. And what I'm going to do is I'm going to say, I want to access the path, but we're going to say that this needs to be of type int. So Pydantic is going to perform some validation. It's going to read it, and every environment variable is always read as a string. And then it's going to try to typecast it into an int. And if it fails, it's going to throw an error. And so since this is clearly not a integer, it should throw an error. So let's try this out. And we can see that value is not a valid integer. Now, for all of the settings and the environment variables, I usually like to create a separate file to hold all of this information. So under app, I'm going to create a new file called config.py. And I'm going to move all of that code into that file. And then in our main.py file, I'll just import from .config import settings. Right? So ultimately, we're just importing that final class, the instance of the class that we created. Right. And so once again, it's able to perform the validation and it's going to report an error with the path variable. All right. So having it in its own file is going to make things a little bit easier because then we could just go to the config.py file and we'll know exactly where to look for all of our environment variables and all the configs related to our application. The last thing I want to do is let's go ahead and actually figure out what environment variables we want to use moving forward and actually set this up. So we're going to clear out all of these and I'm going to create one for all of the database related stuff. So database underscore hostname. This is going to be a string by default. We're going to have database underscore port. Once again, a string. We'll have a database password. And then we'll have a database underscore name. So that's the database within Postgres that we're connecting to. We'll need a username. All of these will be strings. And you may be wondering why the port is set to a string, but the reason why it's going to be set to a string is because if we actually take a look at our database connection, it just goes into a URL, so we don't actually ever need to have it be an int. I guess you could make sure that it's a valid port number and then convert it back to a string, but that seems a little unnecessary at that point. Then there's a secret key for our JSON web tokens. We've got the algorithm for assigning our token. And then we have the access token expire underscore minutes, which is going to be an int. All right. And if we save all of this, we should get a whole bunch of errors, and that's okay because none of these have been set. So at this point, you could technically, whether you're on a Windows or a Mac, set these on your machine and get everything to work. But like I said, that is an unacceptable thing to do because that's a lot of work. And we want to simplify things. So what we can actually do is within our Fast API directory, we're going to create a new file called .env. So this is kind of standard convention, but this file, and don't forget the dot, this file is going to contain all of our environment variables, so we can set it much easier just by having a file do all of the work. Now in production, you're not going to use this. In production, you're going to actually set it on your machine, but in development, it's perfectly okay to just set everything in here. And so what we're going to do is we're going to take all of those environment variables that we defined, and we're going to provide values. And so like I said, in real life, you generally want to capitalize everything, but luckily Pydantic automatically looks at everything from a case-insensitive perspective. And so our database right now is running on localhost, so we can just say localhost. Our database port is going to be 5432. The password, that's going to be whatever you chose to use as your password. It's going to be password 123. And we've got our database name. Mine happens to be Fast API, but yours is going to be something different probably. The username, I'm guessing everyone's probably going to be using the default Postgres. The secret key, I'm just going to grab whatever I used in my file, so I'll just grab this. The algorithm is going to be HS256. And then the access token expiration time is going to be set to 30. So we've got all the values set here. And one thing to note, I didn't provide any default values, and you could 100% go ahead and add default values into yours if you want to, but I'm going to leave them as such. And now we have to tell Pydantic to actually import it from our .env file. And the way to do that is inside this class, we just say class config, and we say env underscore file, and then the path to our specific file. So we say .env. So we'll save this. And I forgot to save my env file. And then I'm going to run this again. And our application should start up with 0 issues.
And so hopefully you guys see how easy it is to work with environment variables, especially when you're allowed to set it on a file so that we don't have to worry about setting it either in the terminal or on a Windows machine, having to go through the GUI to do that. But one thing to keep in mind is that you never want to check this env file into Git, right? Because this has all the credentials for your development environment. Maybe you don't want those to get out, and there's no need to ever check it into Git. So if you create a git ignore file, which is .git ignore, you want to make sure that you put in .env. And we'll come back to the git ignore file when we start working with Git in this course. But you also want to make sure you remove anything with __ PyCache __, which is all of these, as well as your virtual environment folder. So you want to make sure none of those get checked into Git so they don't get uploaded to your GitHub repo. And just to make sure that everything's working, let's go ahead and just test this out real quick, just to make sure that nothing's broken. And that seems to work. And then if we try to get all posts, everything seems to be working. So we have now successfully moved everything over to environment variables. And actually, sorry, we forgot to do one very important thing. We're not actually using the environment variables right now, because if I actually go to my database, you can see that it's still just a hard-coded value. So we have to make sure we actually update that to use the environment variables. So we're going to change this to be an F string. And then here, this is going to be the username. This is the password. This is the host name. And then this is the database name. And then there's also going to be the port number, which would be right here, which is 5432. I believe that's, yeah, and that's going to be the port number. So what we have to do is, since we're using an F string, I can just remove this and I can say, well, first of all, we have to import our config file so we have access to it. Or we can do from config import settings. Just put a dot there. And now I can just say settings dot database, and then we'll grab the username here. And then for the password, I'm going to do the same thing. I'll say settings dot database password. And the host name, this is going to be settings dot database host name. And then this is going to be the port number. And then finally, we've got the actual database name. And I think everything should still work. Just to test this part, let's just quickly log in now. All right, everything still works. So our access to our database is now working just fine. But there's a few other things that I want to update. And keep in mind, if you're using the Postgres driver to actually connect and make queries, then you would just update it here with the settings dot whatever. But if we go to our OAuth 2, we can, well, first of all, let's import our config. And we'll change the secret key. This is going to be settings dot secret key, not schema, secret key. The algorithm is going to be settings dot algorithm. And then finally, this is going to be settings dot access token expire minutes. All right, let's reload this. Let's just double check a few things. So let's create a new user. All right, we were able to create a user. Let's log in that user. We're able to log in, and then let's get posts. And we're able to get posts. And let's just double check that there's no errors. So everything looks good. And so now we have successfully migrated all of our code to using environment variables. And so when we move to production, we can just, on the machine, set all of these values that we have inside our config.py file, and it's going to automatically import it and then update those values wherever we reference them. In any social media type app, there's going to be some sort of a voting or likes system. So Facebook has likes, Reddit has upvotes and downvotes, Instagram has likes, Twitter has likes as well.
And so we're going to implement a simple like system as well. And we're going to quickly go over the requirements for it. So the first thing is a user should be able to like a post. A user should only be able to like a post once. We shouldn't be able to like a post 10 times and then artificially cause the number of likes for that post to go up. And then finally, anytime we retrieve a post from our database or from our API, we should also fetch the total number of likes for that post. Now let's take a look at the requirements for our voting model or our like model. And so naturally, just like we have a table for users and a table for posts, it makes sense to store the votes in another table, just like we always do. And if you think about the requirements or what we should do for the columns, well, we need to have a column that's going to store the ID of the post that we're ultimately going to like. And then we're also going to need a column that references the ID of the user who liked the post. So those are the two absolute minimum number of columns that we need to get our voting system in place. Keep in mind, if you wanted to do an upvote, downvote type thing like Reddit does, then you might want to have a third column for the direction of your vote. But we're going to keep this nice and simple, and it's just going to be a very simple like system. So it's just one direction. But the most important thing of the vote table is that since a user should only be able to like a post once, this means that we need to ensure that every entry, every post ID and voter ID is a unique combination. So what do I mean by that? Well, take a look at this. We have a post with an ID of 12, and this post was liked by a user ID of 4. So this is what an entry would look like. And that's perfectly fine. And if we go here, we've got a post ID of 28, and it looks like a user with an ID of 9 liked this post. And if I go all the way down to here, you'll see that post ID of 12, which you could see that there was already a row with the post ID of 12, is liked by a different user, 9. So it's perfectly okay to see a repeat in this column. And under the user ID section, it's perfectly okay to see a repeat in this column as well, because we can see that a user of ID 9 voted and liked a post with an ID of 28, as well as a post with an ID of 12. And then obviously, one post can be liked by different users. So a post with an ID of 12 was liked by a user with an ID of 4, and a post with the same post was also liked by a user with an ID of 9. Now, what we can't have is a user liking a post more than once. So you could see here, user 2 liked a post with an ID of 55. We can't have him do that again, right? It's a duplicate. This isn't allowed, or this shouldn't be allowed in our system, because we don't want users to be able to like a post more than once. And so there's a couple of different ways of setting up this requirement, but we're going to take a look at the simplest solution. And we're going to learn about something called composite keys. So we've already covered what a primary key is. It's a column in your table that's going to ensure that every single entry is unique. And we always used a column called ID, which had a auto-incrementing integer. However, what we can also do is make use of something called composite keys. And a composite key is nothing more than a primary key that spans multiple columns. So we've only worked with one column primary keys, but we can actually have it cover more than one column. It can have 2 columns or 3 columns. And since a primary key must be unique, this will ultimately ensure that no user can like a post twice if we make sure that both of these columns are part of the primary key, right? And so when you have a composite primary key, it does not care if there's duplicates in one row. It does not care in one column, and it does not care if there's duplicates in the other column. All it cares about is, are both of the columns the same in 2 different rows? So once again, for a post of ID 12, we have a user of 4 who likes it, as well as a user of 9 that likes it. And so with the composite primary key, it sees that as 2 different entries because it needs both of them to be the same to be considered a duplicate. So we can uniquely identify this row by saying, hey, I want the row with the post ID of 12 and a post ID of 9. There's going to be no other rows with that combination. And the same thing goes in the other direction. The user, 9, can like post 28, and he can also like post 12. And so once again, we can uniquely identify either one of these rows because we can say, hey, post 28 with the user ID, that's a unique combination, and a post ID of 12 with a user ID of 9, once again, a unique combination. However, we can't have a user with the ID of 2 like 55, and then once again, the user ID of 2 like 55, because the combination of these two is now a duplicate, because one is 55 and 2, and the other one's 55 and 2. And so that's all a composite key is. It's just a primary key that spans 2 columns and ensures that across both columns, we have unique combinations for things. So let's figure out how to create our new votes table. And I'm going to first show you guys how to do this within pgadmin, so just with regular Postgres, and then we'll take a look at how to do this with SQL Alchemy. And I'm just going to go under tables, and I'm going to create a new table. We'll call it votes. And then under columns here, I'm going to add a column, and this is going to be post_ID. So this is going to be the column that referenced the ID of the specific post. This should, and then actually before we do anything else, I'm going to add the other column in as well. And then we're going to have the user_ID. And so these are both going to be integers. And then we can just select primary key, primary key. And that's going to create that composite key. And then we have to set up the foreign keys as well. So these are going to reference other tables. So for the post ID, we can go into constraints, and then we'll go into foreign key. We'll add a new foreign key. And I'm going to call this votes_posts_primary, whoops, not primary key, foreign key. And actually, sorry, I didn't mean to do that. And then we're just going to go into here. For the columns, we're going to select the local column, which is going to be post ID. Sorry, it's not post ID. Yeah, post ID. And then for the referencing table, it's going to be the posts table. And then we're going to grab the ID of that. And for action on delete, we're going to make sure it's set to cascade so that if the post gets deleted, we're going to delete this entry. And then we'll add that in there. Oh, it looks like it's got deleted. Let me just redo this. We'll add that. And so we've got that in there now. And that should be it for the first foreign key. Let's add another foreign key. And this is going to be called votes_users_foreign key. Columns, this is going to be user_ID of the local table. This is going to reference the users table, and then it's going to reference the ID. We'll hit that. Actions. This is going to be cascade as well. And we'll save that. And then I'm going to right click on the votes table, and then we can go to view, edit data. We'll go to all rows. You can see it's a very simple table. So let's create a new vote first. And so I'm going to, first of all, I've got way too many of these windows, so I'm going to just quickly delete those. All right, so I got those deleted. I'm going to open up a new query. And I can just go into database. We'll do query. And I'm going to do select star from posts, and then select star from users, just so I can get a list of post IDs and user IDs. So I got user ID of 21, 23, 24. And for the post, we got 1049. So let's try those out. And I already forgot them. So let's get that post ID again. So we'll just grab a post ID of 10. So this is going to be 10. And then the user ID, well, I'm going to open up a new window so I can just switch between them. So now we have both of these windows for querying, and I can do select star from users. 21. Okay, so we'll do. And it looks like we hit a bug in pgadmin because I can't write anything here. So I'm just going to do view, edit data, all rows again. And that looks a little bit better. So let's get a post 10 and a user of 21. So 10, 21. And let's see if we're successfully able to get that. And looks like that worked. And then if I grab a post ID that doesn't exist, so let's say like 99, and then a valid user, let's see what happens. It's going to throw an error. That's good. And then if we grab a valid post number, but a ID of a user that doesn't exist, we should also get an error. And then if any of these are blank, hit save, it should throw an error as well. Okay, so our table looks set. That's pretty much all we have to do. There's nothing else for these tables. You'll see that once you can create one table, you can really create them all. So I'm just going to drop this table for now. And in the next video, we'll take a look at defining our model in SQL Alchemy so that SQL Alchemy actually generates the table for us. In our models.py file, let's create our model for our votes table. And we'll call it votes, or just vote. It's going to extend base. And then for our table name, I think it just makes sense to call it votes. Then let's set up our 2 columns. So we're going to have a user ID, and then we're going to have a post underscore ID. So for the user underscore ID, it's going to be a column, and it's going to be of type integer. We're going to set up the foreign key. And this will be users. So it's going to reference the users table and grab the ID field. And then the second property is going to be the onDelete, which is going to be set to cascade. All right, then we'll set the primary key to be true. And that's pretty much it. And then I'm just going to copy this, paste it here. We're just going to change this to be, instead of users ID, it's going to be posts.id. And I don't know why I got auto formatted to a different line. Okay, it looks like that's what it prefers. And so save this, and assuming there's no errors, our application should restart. And then if we go to pgadmin and then refresh, we should see a votes table. And I'm just going to go and take a look at the properties. And you can see that we've got the user ID and the post ID. We've got the primary key set, so it's a composite key. And since it's a primary key, not null is going to be set to yes. We go to constraints. We've got, once again, both the primary keys. We should have 2 foreign keys. And then if we just take a look at one of them real quick, we should see cascade onDelete. And so if we go and view and edit data, let's test this out. 10, 21 again. Oh, sorry, it should be 21 and 10 because the user ID is the first column now. 21, 10, let's try saving that. Good. Let's try doing 21 and 9 or 21 and 88. Should error out, perfect. And then let's try 10 and some random number. Error, perfect. Now there's going to be a couple things that we need to take into consideration when setting up the vote route. So first of all, what is the path we're going to use? And I think it makes sense just to set up a new path called /vote. Just like we have for /users when it comes to handling anything with users, and we have /post for handling anything with posts, we're going to have the /vote for handling voting. Now the user ID, the user who's trying to vote on or like a post, the ID of that user is going to be extracted from the JWT token, so we don't actually have to extract that from the body. We don't need to include it in the body. However, the body itself is going to contain 2 pieces of information: the ID of the post we're trying to like, as well as the direction of the vote. And what I mean by direction is, do they want to vote on the post or do they want to remove a post? Because like any application, maybe you accidentally clicked on a post to like it, but you realize you don't want to like it, so you click on it again to remove that. So vote direction of 1 means that we're going to like the post, and then a vote direction of 0 means we're going to remove our like of the post. Now in our routers folder, we're going to create a new file, which is just going to be vote.py. So this is going to handle all the routing for our voting URLs. And what I'm going to do is I'm just going to copy the import statement from one of the other routers. And we'll set up our route. So let's set up the decorator first, and this is going to be a post. And I actually have to import router. We got it. Let's create our router instance. So we'll say router equals API router. And we'll set up the prefix to be /vote. And the tags, we're going to give it its own section, which is going to just say vote. And so now we can do @router.post. This is going to be a post operation because we have to send some information to the server. And the URL is just going to be /. So it's just going to be /vote then. And since we're going to create a vote by default, we're going to send a different status code. We're going to send a 201 instead of the default 200. Then we'll define our function, which I'll just call vote. Now there's going to be a couple things that we have to pass in. So since we expect the user to provide some data in the body, it usually means we want to define a schema just so that we can ensure they send us the exact information. So let's set up our schema for voting. We'll create a class called vote. And so the first field should be a post ID, which is going to be of type int. And then we're going to have a direction, which is going to be an integer as well. So it's either 0 or 1. However, I would like to be able to validate it to ensure that it's only 0 or 1. I couldn't exactly figure out if there was a way to do that in Pydantic, but one thing we can do is we can use conint. So we'll import that from Pydantic automatically. So if you want to see the import, that's what it's going to look like. And we can say less than or equal to 1. So anything less than 1 is going to be allowed. The only problem with this is that it allows for negative numbers, but that's okay. If you guys figure out how to just specify 0 and 1, then go ahead and replace that, and definitely leave that piece of information in the comments so that anyone else who wants to set up that specific restriction, then we all know how to do that moving forward. And let's import our schema now. So we'll go up a directory. And let's also import database, models, and we're going to have to require the user to be logged in before they can vote on something. So let's import OAuth2. And so here, we're going to set up the schema. And we're also going to set up the database so that we can make queries. And then lastly, we'll get the current user. So once we get all of those dependencies, looks like we have to import session as well. And I'm actually going to move this right below the first import. Not that it matters, but. And so we're going to set up logic for when the vote direction is 1. So if vote.dir, so we're pulling the direction from the vote schema, equals 1, then we're going to perform some logic. Else, if it's 0, then we're going to perform some other logic. So if we want to create a vote, the first thing we're going to do is query to see, does the vote already exist? And so what I'm going to do is I'm going to say db.query, and we'll grab models.vote. And I'm going to filter based off of models.vote.post_ID. And we're going to say it equals vote.post_ID. So we're going to see if there's already a vote for this specific post ID. However, this isn't enough because remember, multiple people can vote on the same post. So we actually have to do a second check. And we can add in a second condition by just doing a comma and then providing the second condition. So we have to say models.vote.userID equals current user.id. And I'm going to save this, and we're going to call this vote_query. So this isn't going to actually query the database yet. This is just building out the query. And it's going to check to see if this specific user ultimately has voted for this specific post already or liked this post. And I'm actually going to move this above the if statement. And you guys will see why we're going to do that in a bit. And we're going to then perform the query and just save that result under found vote equals vote_query dot first. All right. And so if the user wants to like a post, but we already found a post, that means he's already liked this specific post, so he can't like it again. So what we're going to say is if we already found a vote, then we're going to raise an HTTP exception. Now the status code, we're going to use a new status code. I'm going to use status dot, and then this is going to be a 409 for conflict. And there's other status codes you could potentially use. I just decided that this is probably going to be the best fit. And then for detail, we're going to just pass an F string and say user, and then we pass in the user, which is get, current underscore user dot ID. Has already voted on post with an ID of vote.post underscore ID. All right, but if we didn't find a vote, then what we're going to do is we're going to create a brand new vote. So I'll say models.vote. And so the post ID field is going to be set to vote.post underscore ID. And then we can grab the user ID field from current user.id. So this will set the two properties, and we'll save this as new underscore vote. And as usual, to actually perform these changes or to add this to our database, we have to do db.add new underscore vote, and then a db.commit. And we don't actually need to send the created vote back to the user because it doesn't really provide any useful information. We're just going to send a message that says successfully added vote. Now, if the user provided a direction of 0, that means they want to delete a pre-existing vote. So first of all, we'll say if not found vote, right? We can't delete a vote that doesn't exist. So we'll raise an HTTP exception. Status code, I think we could just send a 404. And for the detail, I'll just say vote does not exist. But if we did find a vote, then we have to delete it. So I'll say vote underscore query. Remember, this is the query all the way at the top. I'll say dot delete. And then we can just do our synchronized session false. And we'll do a db.commit. And we'll just return a similar message. Successfully deleted vote. Okay, and this should kind of sum up all of the logic in our path operation function. And at this point, we can just go ahead and test this out. So we'll go back to Postman. First of all, let's log in. All right, so we've logged in. And what I'm going to do is create a brand new request. We'll call this vote. And this is going to be a vote. And in the body, we have to pass in the specific data. So let's actually grab a post or an ID of a post. So in this case, there's an ID of 10. Actually, first, let me double check who I'm logged in as. Okay, that's fine. So I'm going to grab a post with an ID of 10. So here we'll say post underscore ID 10. And then we'll say dir. Actually, is that what we called it? I actually forgot. Let's go to our schemas. Yeah, it's just dir. And this is going to be, this is going to be a 1 so that we can actually like the post. And remember, this should be a post request. So let's try this out. Let's hit send. And it looks like we ran into an issue. So let's check. And it says that this specific route was not found. And so that's obviously because we didn't wire up this specific router. So let's go back to our main.py and let's import vote. And then we can just copy this and wire up vote.router. Yep. And once again, another typo. All right, let's give this a try now. So we'll hit send. It says we're not authenticated. So let me log in user. All right, now let's try this. And it says that I'm still unauthenticated. And guys, I realized why we're getting not authenticated. That's just because we have a new request and we have to make sure that we set the authorization to be bearer token. And then we want to pass in our JWT variable. So it wasn't actually retrieving that. So now if I try this, we can see that we successfully added vote. And just to make sure that it actually did that, let's actually go into our database and take a look at our votes table. And so we liked a post, and it looks like I have some previous ones. So what I'm actually going to do is I'm going to delete everything from our votes table just so we can make sure it works, because I forgot who I'm even logged in as. So let's go to properties. Okay, sorry. Let me just do a query. And I'm just going to say delete from votes. That's going to delete everything in our votes table. Perfect. And then we could just say select from votes. All right, we have nothing in there, and let's try this again. All right, and so now run this. We can see that we did like post 10, and I guess our ID is 24, but we can just quickly verify that. If I do select star from users, and I'm logged in as Sanjeev123, so we can see that that has an ID of 24. So that works. Now, what I'm going to do is let's test to see what happens if I try to vote on a post that I've already voted on. So I'm going to keep the vote direction to be 1, and I know I've already voted on this post. So we should get user 24 has already voted on post 10. Perfect. Now let's go and try to delete a post. So I'm going to set the vote dir to be 0, and let's see what happens. It says I successfully deleted the post. Or the vote, and let's just do a quick query. We can see nothing is there. And then if we try to delete a vote or a like that doesn't exist, we can see that vote does not exist. All right, guys, so we've actually implemented all of the voting logic right there. The only other thing that we need to do is when we retrieve a post, right, whether it's through the get all posts or even a get one post, I want to have my Fast API send the number of votes as a property, as a field here, so that when we load up posts on our front end application, they can see the number of likes that a post has. That's usually how most applications work, and I would like it to have it automatically send that information instead of having to send another query to our backend to see what is the total number of votes. I want it to do it automatically anytime we retrieve any post, and that's going to be a little bit more complex. We're going to have to learn a little bit more about SQL, start digging into some of the weeds of SQL and Postgres. And then once we learn how to do it with regular SQL, we have to see if we can do this with SQL Alchemy. After I finished recording all of the voting logic, or at least the router that handles voting, I realized there's one tiny bug. And that is that right now, there's no logic to actually detect if the user's trying to vote on a post that doesn't exist. Because if they want to vote on a post that doesn't exist, I want to ideally send a 404. So what we're going to do is we're going to implement that logic, and it's going to be really simple. We're just going to query for the post based off of the ID first. If it doesn't exist, we're going to throw an exception. So just like we've done with pretty much all of our other routers, whenever someone tries to access a post that that doesn't exist, then we're just going to simply send a 404. So let's start off by making our query. I'm going to do db.query. We'll say models.post. And then what we're going to do is we're going to filter based off of the post ID. So we'll say models.post.id equals vote.post_ID. And then we're going to grab the first one. And we'll save this in a variable called post. Then we'll say if not post. So if the post doesn't exist, then we're going to raise an HTTP exception. And the status code is going to be a 404. And the detail will be the usual F string that says post with ID, and then we'll pass in the ID. Does not exist. And that's all we have to do, and that's going to fix that little tiny bug. And you'll see that when we get to the testing section, we can now test to see if the post doesn't exist as well. Up till now, we've been working with very simple queries. We've just been querying a single table. However, now that we have more than one table, and all of these tables have built out these relationships, you're going to see that eventually you want to be able to get information from two tables at the same exact time. And this gets a little complicated, but the way we actually do that is by using something called a join. So we join two tables together. And as an example, let's say I want to get all of my posts. So I do a select star from posts. That's great and all. However, when we're sending back the posts to the user, right? Our front end has no idea what a owner ID of 23 is. He doesn't know what that is. And we ultimately want to display the username or the email of the user that created that post on our front end. So what we would have to do, if we could only retrieve data from one table at a time, is we'd have to then individually go and then fetch all of these users from the user table one by one, so that we can actually get the email or the username. And that's a little inefficient, having to do multiple queries. If you ever get a chance to, it's better to just do a single query and get all of the pieces of information that you're interested in. So I'm going to show you guys how we can join information from two tables, because I would also like to get all of the user information based off of the owner ID field that's on the posts table. So how do we do that? Well, we start off a query just like this. And actually, before we go into this, what I would like to do is show you one of my favorite websites. So if you go to Postgres tutorial, just search for that in Google, you'll see that there's a website called PostgreSQLtutorial.com. This is one of my favorite sites. And I want you to go to joins right here. So this is how we get information from two different tables. And this page does an absolute marvelous job of explaining how to actually join two tables. And it goes over the different types of joins, because there isn't just one method. You've got left joins, you have inner joins, you got outer joins, you got right joins. And I strongly suggest you guys quickly just kind of read through this just to get an idea, because I don't want to cover every single join. I'm just going to show you the ones that we need to get the data that we're interested in. So let's go back to Postgres and let's create our first join. So here I'm do select. I'm just grabbing all of the fields and I'm going to grab it from the post table. And what we can do is I can say left join. And then we specify the other table we want to jam into my query. So now I want to get data from the users table. So I do users. And then we have to find a field in both tables that we need to match on or join the table on. And since we want to find the specific user associated with the person who created this post, we need to join on the owner ID. So what we say is on. So this is how we specify what it should join on. And we want to say, we grab the first table's name, right? The posts table. So we grab posts and then we say dot, and then we grab the specific column we want to join on. So owner_ID. And then we just say it equals to, and then we grab the second table, which is called users. And then we grab the specific column from the users table we want to join on, which is users.id. So now if I run this, take a look at that. It took all of the user data and it jammed it right into one single query with the posts. And so now I get the entire post, and I also get information about this specific user because we joined on owner ID and the user ID together. So I was able to kind of take that information from the other table and match it right up to here. Because we did a star, it's going to grab the columns it's going to grab every single column from both of the tables. And there may be times where maybe you don't want that. Maybe we just want a couple of columns. So let's say we want the title column, maybe we want content, and maybe we want email. right? And this should allow us to grab the title, which comes from the post table, and the content, which comes from the post table, and then email, which comes from the user table. So let's see what happens when I run this, right? You can see I got the title, content, and email. Now, if I remove this and go back to everything, just real quick, let's say I want to get the post ID and the email. Well, let's see what happens. I'm going to do ID and then email. Well, it looks like we have an error. It says column reference ID is ambiguous. So what exactly is happening here? Well, I'm going to remove this and show you exactly what happened. The problem is that the post table has a column called ID and the user table has a column called ID. So when I just say ID, it has no idea which column I want. So that's why it's saying it's ambiguous. So what we need to do is anytime there's a potential for confusion, we always have to specify the table name before it. So I can say posts.id, and then I could say email. Now, I don't have to say, user.email because only the users table has an email column. However, if there was an email column in the post table as well, then we would have to append the table name first. So you only need to do this when there's confusion. However, if you want to just kind of stick to a certain convention, you can just set up every single property to have the table name beforehand so that you know which table it's coming from. Makes it a little bit easier to read. And so now I got just the ID and the email. Now let's say I want to get every field from one of the tables. I can say posts dot star. That's going to grab every field. So it's grabbing the post table, and then the star means, hey, grab every single column. And so I could do that. It's going to grab everything from the post table, and then I can grab maybe just the email in this case. And so this kind of ultimately does what we had wanted it to do, because I told you guys we want to be able to get the email or the username information for each and every single post. And if we want to, we can add in some of the other fields, maybe the user.id. So the user ID, however, that's just going to match up with the owner ID. But just to show you guys, there is some flexibility. And as I mentioned before, there are different types of joins. There's left join, there's right join, inner join, outer join. I don't want to spend too much on it, but I do want to cover just a few things. All right, so the direction references which table. So right now we're working with two tables. There's the first table that's referenced by from, and then the name of the table. And then there's the second table, which is referenced after the join, which is right here. And so the first table that's referenced is always referred to as the left table. And the table on the right, the second table that's mentioned is always going to be the right table. So you got the left table and the right table. And so when we do join, what it's actually doing is, well, I think this page actually gives us the best explanation. So a left join selects data from the left table. And I don't know if this is big enough for you guys, but I'll zoom in. So it's going to select data from the left table. It's going to compare the values between the two columns that we have selected. And for us, in this case, it's going to be post.ownerID on the left side and then users.id on the right side. And it's going to find where those values match. And if they are equal, the left join creates a new row that contains the columns of both tables and adds this row to the result set. And what's important is in case the value does not equal, the left join also creates a new row that contains the column from both tables and adds it to the result set. However, on the right side, the value is going to be set to null. So if we ever had a post that didn't have an owner ID, then what would happen is we would see the user information all set to null in that case, or the email would be set to null. However, since the way we set up our table is that every single post must have a owner ID, we're never going to run into that situation. Now, before we move any further, just to show you guys what a right join is, it's the exact same thing, but in the opposite direction. And so let's take a look. And things look a little bit different now, because what's happening is that we're going to go through the two tables and find if the owner ID and the ID of the user match. And we're going to join it on that. And we're going to do this for every single entry. And then at the end, you could see that user 24 has no information on the left side. And that's because user 24 didn't create any posts. So the right join will show you instances where something exists in the right table, but it doesn't exist on the left table. The left join will show you something that exists in the left table, but doesn't necessarily exist on the right table. But I'm going to change this back to left join. And now what I would like to do is, it would be great if we can get the number of posts by each user, right? How many posts has each user created? So is there a way to do that? Well, there is actually. So what I'm going to do here is I'm going to grab the users.email, actually users.id, and maybe we want the users.email as well. Actually, we'll just get the ID. And here at the end, I'm going to say I want to group by users.id. So we're going to find all of these entries in our join and then group them based off of the user ID field from the user column. And so once we group them, we can then actually count up all of the columns. All of the entries on a per user basis. So if I say user ID, and then we say we can use a built-in Postgres function. And here, if I put in star, and I'll come back and explain what this means, we can hit run. And we can see that the user with an ID of 21 has 11 posts, and the user with an ID of 23 has 2 posts. The only issue is, if I actually do another query right here, and do select star from users, there's actually 3 users, right? And one of them hasn't made any posts, and so that's why we don't see it in that list. And if we want to be able to see it in that list, we need to actually change our query. And like I mentioned, the right join, if I actually remove the count column right here, and we just do a star, this is going to actually list every single user, even if the user has no posts. And so if I remove the group by ID real quick, right, you could see down here, I have user 24 with no posts. That's exactly what we want. And so now I can say group by users.id. And then here I'm going to say select users.id, and then we grab the count. So let's see if this works. And notice how all of the post fields are completely empty. So that's perfectly fine. And then we can run this. And you can see that it seems to have worked, right? User 21 has 11 posts, user 23 has 2 posts, and then we got user 24. But it says that there's a value of 1. And the reason for that is that when you do star right here, that means it's going to count null entries. So since we have that 1 null entry, it's going to count that as 1. So instead, what we're going to do is we can actually pass in the name of a column. And so once again, I'm actually going to copy this, paste it into here. We're going to remove the group by. And then just do a star. So we're going to get every entry, except because we did count star, it always ends up counting this as 1. So that user 24 is always going to have 1 entry, but that's not accurate because he doesn't actually have any. So instead of doing count star, we can actually pass in a column that we want to count. And so in this case, we can pick any of the posts column that we're trying to retrieve. And so I can just say post.id. And so when you pass in a column name, it does not count columns that have a null value. So if the user doesn't have any posts, he won't have anything under post.id. And then if I just remove this query and then run this, you can see that now I have successfully gotten the exact query that I want. And I can rename this column as user underscore post underscore count or something. That's a little bit more readable. And then, I can grab any other field that I want. Maybe I also want the users.email. And so that way we get just the information that we ultimately want. So you can see that doing these queries, they do get a little bit more complex, and you have to practice this a lot. And so I definitely recommend you actually just read through this document, set up a few example tables, and just practice doing your queries. But we're going to spend just a little bit more time on these queries so that we can figure out how to get the total number of votes. It is a little bit longer of a process, but I want to make sure that you guys understand exactly what we're doing. All right, guys, so let's move on to working with our posts table and our votes table. So I'm going to do a join on those two. So let's start off by doing select, and then we'll just do star for now. And we'll say select star from, and then in this case, posts. And keep in mind, guys, I mentioned that the first table you reference is the left table and the second table that you reference is the right table. It doesn't actually matter which one is the left or right. The only thing that matters is that you set up the right direction of the join. So if we set up posts as the left table and we want to do a left join, then if we ever rewrite our SQL query and set up our votes table to be the left table instead, then we would just have to flip the join to be a right join. So it doesn't matter which table comes first. Keep that in mind. So you don't have to start your query on just the posts. You could do this on votes as well, and you just change the direction of the join. But I like to do posts. And then we're going to try a left join once again. And we'll say that the other table is going to be votes, and we're going to join on, well, if we take a look at our votes table, which I'm actually just going to cut this out real quick and save that in my Scratchpad. I'm going to just say select star from votes. We'll run that. Right, so there's going to be a user ID and a post ID. And then if I do a select star from posts, we have all of these fields. So I think you guys can guess the exact column that we would need to join on. So we need to join on post.id and then votes dot post underscore ID. So whenever those match, we need to get a result. So I'm going to go into my application and just run a few, I'm just going to vote on a few posts so that we actually have some data. So I'm logged in as a user and I'm going to vote on post 10. All right, we successfully added votes. I'm going to get a whole bunch of other posts. I'm going to vote on post 4 and 9. All right, and I'm going to log in as a different user now. Let's see who else I got. All right, I'll just log in as Sanjeev, I guess. My login. All right, we've logged in. And I'm going to vote on post 10 as well on this guy. And then we'll grab some random vote, 15. Okay, and so we should have a decent number of votes now. And I purposely made it so that one of the users didn't vote, just so that we can take a look at what complications that add. All right, so we have all of these votes. We've got the user ID and the post ID. So now let's set up a join. So I'm going to do select star from posts. And I'm going to start off with the left join. And we'll say we want to join with the votes table. And the field that we're going to join on is on the posts. We're going to grab the .id and wherever this is equal to votes.post underscore ID, we want to join the table. So let's run this. And let's see what results we get back. All right. And so you can see that, hey, look, a post with an ID of 10. It looks like it does have a vote. So this is one join right here. But then you'll notice that if I go down, you'll see another entry. So this doesn't mean in our database that we have two posts with an ID of 10. It's just saying that since we joined them, we have to go down the list, see where they match, and then print out a row. So it's going to print out a row for every single time the post ID matches the post underscore ID of the votes table. And so since we have two votes for the same exact post, that means we're going to get two different entries. Doesn't mean there's actually two posts in our table. It's just the way that the joins work. And I strongly recommend, like, if this is still a little confusing, keep reading that document and play around with it. If you want to see the opposite, actually, before we take a look, let's just take a look at a few other things. You can see we've got post with 4, and we can see that there's one vote for that because there's no other entries here for an ID of 4. And then we could see all of these posts that have no votes whatsoever. So that's what the left join gives us, because anytime we have a post, which is the left table, since we do a left join, it's going to list those posts, and it'll just put null on the right side. Whereas if we change this to a right join, it's going to do the exact opposite. With the right join, right, once again, it's going to look for any time the ID here matches the post ID, and it's going to spit out a row. And then the same thing goes for the post with an ID of 4. And then once again, you can see 10 shows up twice because 2 users voted on it, and then 15 and so on. But then you'll see nothing else. And the reason for that is we did a right join. So it's going to show us all of the votes and their corresponding post. However, it's also going to list out any votes, because it's a right join, that aren't associated with the post. Now, all of our votes have to be associated with the post because we put in that constraint, that check. So that's why we don't see anything with the null on the left side, because that's just the way our tables have been set up. So hopefully that didn't confuse you guys. We're going to change this back to a left join. And what we're going to do now is we're going to do, I want to be able to count the total number of votes for each and every post. So we're once again going to do the group by. So we're going to group by posts.id. So we'll group them together and then count them. And for columns, I'm just going to say, we'll say posts.id. And then we want the count. So we'll start off with the star and let's see what happens. Okay, so we can see that, post with an ID of 10, we know it has 2 votes. But then everything else has a value of 1. This is not correct. We know that a whole bunch of posts don't have a value of 1. But like we covered in the previous lesson, anytime you have a value of null, then it's going to count that as 1. So I'm going to run the previous query, remove the group by, and I'll show you guys exactly what I mean. So now if I run this, oops, this should be a star. All right, look at all of these posts that have a value of null. It's going to count them all as 1 in this case. And we don't want that, right? And that's what happens when you do star in the count field. So instead, what we're going to do is we're going to provide a specific column to count on so it doesn't count the null values. So what column should we use? We can really use any column. I think it makes sense just to do, we have to grab one of the columns that are null in this case. So we'll get votes.post_id. So now, look at that. We get the post ID, and then we get how many votes they have altogether, or how many likes. And instead of just grabbing the ID, I'm going to actually grab everything from the post table. We can run that. And this is the exact query that we're looking for. We get the post information, and we get the number of votes. And we can rename this, because I don't like calling it count. We can rename it as, votes or likes. It doesn't really matter. And there you go, guys. And if you guys want to query for an individual post and get the total number of votes, it's actually very simple. It's the same exact query. We're just going to provide a where condition. And so here I can just say where post.id equals 1. Well, actually, I don't have a post ID of 1, so I'll grab a post ID of 10. And so now I get my 1 post, and we can see that he should have 2 votes. All right, and so that's how we do this with raw SQL. Hopefully this wasn't too complicated. Like I said, I strongly recommend you spend a little bit of time going over joins and practicing it with your own tables. Don't just use posts and votes. If you can probably come up with simpler tables to work on this and understand it a little bit better. But I think that's going to wrap up this video. And so go ahead and just save these queries for now so that we can reference them later. In the last video, we saw how we can gather information from 2 different tables by making use of joins. And so we saw how to do that with raw SQL, and now we're going to see how we can perform joins using SQL Alchemy. And if you go to your post router, we're going to go to the get posts path operation. And so we're going to kind of just take this step by step and see how we can slowly build out this query so that we can actually perform a join. And if you take a look at the current query, what we can do is just ignore all of the filter stuff first. And so really the meat of this query is just db.query, and then you pass the model, and that's going to get every single post that we have in this table. And then we perform all of these filters to kind of drill down. So we're going to start off with the same thing, and I'm going to save this new query as results. Or we could just say posts underscore votes maybe, and we'll just save it as results. And so we're going to start off with the same exact query. We're going to do db.query models.post. And then we're going to perform .all. Actually, remove the .all. And the reason I don't want to do the .all is I don't actually want to query the table. I just want to actually see the raw SQL that it's generating. And now we can do a print results. I'm going to bring this up a bit, and we're going to just send a query to the get all posts. And you can see the raw SQL that it generated. So it's going to select and then basically select every column and then rename it accordingly. And then it's just going to get that from the post table. So it's getting every single post. That's all. So everything is pretty straightforward at this point. And if we go back to our PG admin, let's actually take a look. Let's take a look at what our SQL query actually looks like. And so you can see here, there's a whole bunch of things going on, but the next thing I want to do is I want to actually start to perform the join. So I want to join on the votes table. So let's take a look at how we can do that. And to perform a join with SQL Alchemy, I can just say join. And then we have to specify the table we want to join. So this is going to be the models.vote. And then the second thing is what is going to be the column that we perform a join on. So in this case, you can see that we're performing a join on post.id and votes.post_id. And we're going to do the same thing here. I'm going to say models.vote.post_id equals, and then we'll say models.post.id. Whenever they're equal, we're going to join the table. Now, the thing about this join is, by default with SQL Alchemy, this is going to be a left inner join. And the word inner is going to be a little bit new for you. And that's because there's two different types of left joins. You've got left inner and you have left outer. And I don't want to spend too much time kind of diving into what's the difference. Just know that if you ignore the keyword, it's going to by default be an outer. So what we want is an outer join. However, SQL Alchemy by default uses inner joins. So to actually set this as an outer join, we have to pass one more thing, which is going to be is outer equals true. So this is going to make this a left outer join. So we've got our join at this point. And what I'm going to do now is save this again. And let's take a look at our query. So we'll send something. And now we'll take a look at our query. We can see that, okay, we're going to select everything from our post table. Then we're going to perform a left outer join with votes on the table votes whenever votes.postid equals post.id. So we're almost there. The next thing that we have to do is we have to group by post.id, and then we have to perform the count on votes.post_id. And so if you can take a guess as how to do group by, we can just do .group_by, and then we specify the specific column. So we'll do models.post.id. And then we have to get the count. So we'll go here, and I'm going to say, well, first of all, we have to import a function. So what you're going to do is from SQL Alchemy, import func. And so this is going to give us access to functions like count. I'm going to say func.count. And then we'll say models.vote.post_id. We'll save this, and I'm going to send this, and let's take a look at the query once again. And so we've got select posts, all of the post columns. Good. And then we get to count, right? And it's going to perform the count. That's all right. However, we're naming it as count1. I don't like that. I want to name this something that I will understand. So maybe something like votes. So we have to figure out a way to rename this column. And if you want to rename this column, you just say dot label and then the name that you want to give that column. So we're going to call this votes. And so let's test this out one last time. And now we can see that the column is called votes. So this is exactly what we want. This is the exact query that we generated in PG admin manually. We're just doing it through SQL Alchemy. And what we're going to do is, well, let's actually perform the query. We'll do .all. I don't need the print anymore. And we're going to actually return results, and let's see what happens. So now if I send a query, it's giving me a whole bunch of errors. And if we scroll to the top of the errors, we can see that these are all Pydantic validations. And so it's saying that, hey, there's no title, there's no content, there's no ID, there's no owner ID, there's no owner. All of these fields seem to be missing. And why exactly is that? Well, let's take a look at the response model. So the validation is happening because we use this response model of schemas.post. And so if we go to schemas and we find our post object, our post class, you can see that it expects an ID, a created at, an owner ID, an owner, and all of that good stuff. And it's saying that none of these have been set. So it looks like there's something wrong with our query. But just to make this a little bit simpler, what I'm going to do is I'm actually going to remove the response model. So I'm going to just comment out that. Remove the response model so we're not actually performing any validation. And we're going to see what this looks like now. So when we retrieve the data, I want you to take a look at what this looks like. So this right here is one specific post. And so after our changes, we can see that we've got a property called post, and then within there we have ID published and so on, and then we've got a property of votes. And I'm actually going to copy this as an example. And I'm just going to create a new file. And I'm just going to say, we'll just call this example.py. That's fine. It doesn't really matter. We'll delete this in a bit. So this is what it looks like. And when we go back to our path operation, I'm going to return posts. And we can actually return the response model just to see what that looks like. And so now if I do a query, I need to save. Right, if you take a look at the query, this is what it looks like in a working state before we set up the joins. And if I go down to my example, where's my example py file? So this is what Pydantic expects. It expects to get an object with a field of title, content, published ID, and so on. However, after our join, something odd happens. We have a field called post. And that breaks everything because it doesn't expect the ID and the published and the owner to be under this essentially this dictionary right here. And that's why it's throwing all of these errors. So how exactly do we fix this? Well, what we're going to do is I'm actually going to go to my schemas, and I'm actually going to create a new schema. So we'll call this, you can call this whatever you want. Maybe post vote, or I'm just going to call this post out. And it's going to be a post base. It's going to expend post base. And what we're going to do is we're just going to try to match this as close as possible. So this is going to represent a post object, and then we're going to have a field called votes, which is going to be an integer. So here I can just say we have something called post, and don't forget to capitalize it because our query, for some reason, returns it with the capital P. It took me a little while to figure that out. I was running into a few issues. But we can go here and we could say, I want to return, I want this to be of type, and then we'll reference this post. Right? So all of these fields will be under a field named post. And then we expect something called votes, which is going to be set to an integer. So let's try this out, and we'll go back to our post.py, and I'm going to reference post out. And we're going to return results again. And let's just make sure there's no errors. It looks like it's good. And let's see what happens now. All right, we got a little bit of an issue. And it looks like there's a title, content, a whole bunch of errors. And so the title and the content are missing for both. So what did we do wrong here? This should have fixed our issue. Well, let's try adding this class config ORM. I think that might actually be what's causing this problem. And now let's try this. That didn't look like it fixed it. All right, guys, so I was playing around with it, and then I don't know what exactly fixed it, but all I did was I had changed this to a lowercase p. And this led to, us seeing this specific issue where it says, hey, this post doesn't exist. And then as soon as I recapitalized it, all of a sudden it started to work again. It starts to work now. So I'm not really sure why it broke in the first place. I didn't change any other code. Just looking back at my path operation, you can see that I'm now changing my response model to be schemas.postout. And then we're performing the same results query and then returning it. For some reason or another, it's now properly working. I have no idea what changed. I have no idea exactly what changed, but it's working now. So hopefully you guys don't run into any issues, and hopefully it was just some kind of issue on my machine. But if you do run into the same issue, just try moving it to a lowercase.
try restarting the application, then changing it back. I have no idea why that would fix it, but seems to have done something. And so now our results are perfect. We get the post information. We still fetch the owner, which is fantastic. And then we have the votes. And then just double check to make sure that all of your votes are all okay. And so it looks like they all look good. I know that one had 2, and then the rest should all have 0. So everything's looking pretty good. The next thing that we need to do is actually go ahead and add our filters back in. So let's see if I can still filter on all of these. And so I'm just going to copy this. And then before I perform the dot all, I'm going to paste that in there. Oops, I forgot to copy. All right, and then let's test this out again. All right, things are still working, but let's just add a few extra query parameters. So I'll say search equals beaches. All right, and then it looks like it should only return posts with the word beaches. And then let's try limit equals 2. Remove the search for now. And that works too. So it looks like we get to keep all of the same functionality that we had before. So I'm going to just write this as posts. We're going to comment this out just for reference. And then we're going to return posts like we normally do. Send it one more time. And it looks like everything is still working just fine. Perfect. So we finished the get multiple posts path operation, or get all posts. And I noticed that we do have to go ahead and update the get individual post, because right now, if we go to get one post, you can see that we do not actually get the vote count for that. So we definitely want to see that in here. And we're going to have to perform the same exact join. So I'm just going to copy the previous query all the way up to before the filter. So just copy that part. Say post equals, paste that in there. And then we can filter, copy this filter at the end. And that should ultimately get us what we want. I'm going to comment this one out. And keep in mind, we have to return post out instead of post now, because we want the new format with the votes. So now if I hit send, name post is not defined. Oh, okay. Misspelled that. And looks like we fixed that one. And then it's really up to you to see if you want to, kind of worry about creating posts and updating posts to make sure that, when they create an update that they return the number of votes, but it's ultimately up to you. I think we don't need it in those. This is more of just kind of returning back just the main information about the post, and then, the queries for updating a specific post and then grabbing the votes gets a little complicated. So we're going to ignore that for the update and the create post functionality. Now, when it comes to building out the tables or the database schema, SQL Alchemy has a little bit of a limitation, and that is that SQL Alchemy doesn't allow us to modify tables. It doesn't allow us to create extra columns, delete columns, add foreign key constraints. And that's because when we define these models, what SQL Alchemy does is it checks to see if the specific table name already exists in our Postgres database. And if it does, it's not going to touch it. So if we make any changes, it will never push out those changes. It'll only create these tables if it doesn't already see a table with that specific name. And so we've had to resort to dropping all of our tables and then restarting our application so that SQL Alchemy builds it from scratch. And it's something we can't obviously do in production. That would be an unacceptable thing to do. And just to show you guys, in case you've forgotten, if we go to our Postgres database and we go, we can see that we've got our 3 tables. Now, if I add a phone number column to our user class, and I'll set this column to be just a string, and this is really just for demonstration purposes. You guys don't have to do this. If I save this and reload this,
SQL Alchemy will not go into Postgres and actually create that column. If I refresh this and then go into users properties, you can see that it is not here. And so that's the limitation of SQL Alchemy. And so in this section, what we're going to do is we're going to take a look at another tool that'll allow us to do a couple things. First of all, it's going to allow us to automatically update the columns based off of the models that we define here. So moving forward, when we add this phone number column, it's going to automatically update our Postgres database. And this tool is called Alembic. It is what we refer to as a database migration tool. However, it's much more powerful than that. Right? It's able to allow us to create incremental changes to our database and actually track it, kind of like we do with code. So in this lesson and in the next coming lessons, we're going to take a look at Alembic. We're going to see everything it has to offer. And I'm going to hopefully get you guys at least a solid understanding of how to work with Alembic so that when you guys work on your projects, you can immediately get Alembic installed, running, and then manage your databases using Alembic instead of having to either do it manually or use any other kind of unusual workaround. Now, one of the motivations for a database migration tool came from the fact that developers can track changes to their code and roll back their code easily with Git. And they wanted to be able to do the same thing for our database models and our database schema. And so they went about implementing what is referred to as database migration tools. And so a database migration tool just allows us to incrementally track changes to our schema and roll back those changes to any point in time. And so as we go through our project, we kept adding new tables and new features. What a database migration tool is, it's going to allow us to track those changes. And so if we ever want to go back to a specific point in time so that we can kind of troubleshoot code at that point in time, it's so easy. It's just one simple command and it's going to automatically update our database so that the schema matches what it was at that specific point in time. And so that tool that we're going to use, like I mentioned, is going to be Alembic. And what's great about Alembic is that it can also automatically pull all of our SQL Alchemy models and generate the proper tables based off of that.